discussions and meaningful exchanges on the future of heavy haul operations. It is an honor to welcome you back to the second day of the Internationl Heavy Haul Seminar. Today, we continue this journey of learning, innovation, and collaboration as we delve deeper into the challenges and opportunities shaping the heavy haul sector. We begin the day by inviting the moderator for the first technical session today, which is also the fourth technical session of this two-day seminar. Since we have 6 speakers in this session, it is a long session. We will break for tea at 11 a.m. and then resume at 11:15 to continue with the proceedings of this session. The topic of this session is OHE and signaling systems for high-capacity freight corridors. And now I invite the moderator for the session, Shri CHHRR&D, who is a distinguished Indian Railway Service of Signal Engineers, that is IRSSC officer of the 1987 batch, with over 35 years of rich experience in railway signaling, telecommunications and train control systems. An electronics and communication engineer and a law graduate from Government Law College, Mumbai. He has held several key leadership positions, including Principal Chief Signal and Telecom Engineer at Western Railway. Currently serving as Advisor, Signal and Telecom to DFCCIL, he is steering the implementation of critical initiatives such as Kavach and centralized traffic control across dedicated freight corridors. Shri CHHRR&D has played a pioneering role in introducing several technologies first in Indian Railways, including the country's first Tetra-based mobile train radio communication system, the first direct drive electronic interlocking, and the rollout of the indigenous Kavach train protection system. He has also championed innovative safety solutions such as landslide alert and lion intrusion detection systems using the distributed acoustic sensing technology. He is also visiting faculty at Gati Shakti Vishwavidyalaya, Vadodara, contributing to the development of future railway professionals. Please join me in welcoming Shri CHHRR&D. जोरदार तालियों के साथ स्वागत करते हैं, and I request you, sir, to please begin the proceedings of the day.
Thank you, Juhi, for such a nice words. High-capacity freight corridors demand not only strong infrastructure, but also intelligent systems behind it. Good morning, ladies and gentlemen. I welcome all of you in this technical session. Our first technical session today focuses on OHE and signaling system for high-capacity freight corridors. Yesterday, we spent considerable time discussing track, infrastructure, and asset conditions. This morning, we turn our attention to the systems that allow heavy haul railways to safely convert infrastructure capacity into train movements. Track may carry the train, but signaling, train control and communication systems determine how effectively that infrastructure can be utilized. As freight corridors become denser, more automated, and increasingly data-driven, reliability depends not only on physical infrastructure, but also on intelligence embedded within railway systems. The papers in this session therefore explore how signaling, train control and maintenance strategies are evolving to support next generation of high-capacity freight corridors. Before we begin, a brief reminder regarding timings. Each speaker has been allotted 20 minutes, a single bell at 17 minutes, and 2 bells at 20 minutes will indicate their balanced time. Questions will be reserved until the end of session. Slips will be circulated, which can be passed on to me by writing your name and named speaker. We start with our first paper of today's session, to be presented by Mr. Manish Kumar Chauhan from Hitachi. It is fitting that we begin with this session close to our home on DFCCIL's own Western Corridor. As heavy haul railways become increasingly dependent on system availability, signaling assets must evolve from being maintained on fixed schedule basis to being managed through intelligent and condition-based approaches. Hitachi is a global leader in railways, signaling and digital technologies, and our first speaker will provide a practical case study from the Western Dedicated Freight Corridor itself. Please join me to welcome Mr. Manish Kumar Chauhan. The top title of his topic is Smart Maintenance Solution for Signaling Assets on Western DFC. Over to you, Mr. Chauhan.
Thank you. So, welcome friends. So, this paper presents a case study of implementing a smart maintenance solution for the signaling assets on WDFC phase 1 section. This combines the remote monitoring, remote condition monitoring, predictive analytics, and enterprise asset management as an integrated solution. So I will be covering basically the 4 topics. The overview of signaling system deployed on this section for the audience who are not familiar with the DFC, and then the necessity for this smart maintenance and optimized maintenance solution along with the global scenario in this arena. Then the solution itself, what is the solution and how we are creating the value out of it. And the last but the most important thing is the change management. So these kind of systems are not only the deployment of technology, but because it intervenes with the maintenance of the railway system, which is highly human-centric. Therefore, it is a journey of change and transformation. So, very important, starting with the quote, that the change is hardest at the beginning, messiest in the middle, and the best at the end. So, when we go to deploy this kind of solutions, we have to be ready for the entire journey of transformation. Okay. So, starting from the introduction of signaling system. So basically DFCC has 2 kinds of stations if we categorize as a junction station and the crossing station. And the block sections are quite lengthier, 35 to 40 kilometers with automatic signaling and wayside signals at every 2 kilometers. And equipments are located at stations and auto locations huts in the block section connected by optical fiber cables for communication. So the purpose to show that assets are widespread into the geographically, and there are a lot of unmanned locations where the signaling equipments are kept. At stations we have basically interlocking track direction system, which is the axle counter, and power supply basically to maintain. And the similar kind of equipments are there at the auto location huts as well. And what is expected from the system? The characteristics I told that geographically wide spread assets itself calls for the remote condition monitoring for ease of maintenance. But together with that, the nature of freight corridors, dedicated freight corridors, calls for the very, very high availability of the system and optimized operational efficiency and enhanced life cycle cost. Interesting fact about the total, if we talk about the total cost of ownership, only 25% of the total cost of ownership occurs in the beginning as a capex. 75% is during the operation phase of the asset. So there is a ample opportunity to optimize this cost and improve the availability at the same time. Then why we need the smart maintenance and what is the smart maintenance basically. So smart maintenance is, if I say the right maintenance at the right time, not more than that. And why do we need it? Already we discussed, for improving the availability and optimizing the operational cost. So with that, so if we say always the more maintenance is equal to more reliability, so that's not true actually. So the periodic maintenance replaced with the better maintenance strategies or optimized maintenance strategies may improve the reliability. And the modern asset management recommends the optimized maintenance strategy based on the reliability-centric maintenance, which is a blend of periodic maintenance and the condition-based and predictive maintenance, especially for the applications, safety applications like railway signaling, where safety critical checks are mandatory and cannot be achieved by the remote condition monitoring and predictive maintenance. And some of the hidden part, like changeover to standby equipments, predictive plant maintenance is anyway required, while the functional checks can be fully transferred and replaced by the technologies and the data analytics approaches to proceed with. If we talk about the deployment, the enterprise asset management, condition monitoring, and the data-driven approach for the predictive analytics can combine as a reliability-centric maintenance. So what we can achieve out of this? First is the resource optimization. Based on the data gathered, if we rely on the data gathered by the condition monitoring system, we can eliminate the repetitive PM task, which becomes redundant if we already have those kind of equipment performance data with us through the digital systems. And we can save, report says that we can save up to the 50% of the maintenance efforts by eliminating such tasks. And reliability improvement is the second one, the most important. And only by condition-based maintenance, the movement to the track will be improving the operational efficiency as well as improving the safety of the people working on the track, as well as requirement of the block, the traffic block to carry out the maintenance will also be reduced. So what is the global scenario in this area of applying the digital technologies for maintenance? So yesterday's sessions, we have seen a lot of examples for the track and the rolling stock. So that is already proven in several countries. But I could find two examples of applying this for the signaling system on network rail. And their published report says that by optimizing the scheduled maintenance task by condition-based monitoring, 50% of the maintenance efforts can be optimized. And under this program of reliability-centric maintenance, approximately 3,67,000 assets are transferred to this system by network rail, and they have demonstrated the results. So now coming to the solution that we have deployed on WDFC. It combines the enterprise asset management, remote condition monitoring with predictive analytics on the section Rewari to Makarpura, covering 930 kilometers. So I will explain the solution in brief. So basically, the first layer of the solution is the remote condition monitoring itself. And the equipments, we have covered the entire signaling system because we can achieve the results when we cover the entire system. Otherwise, if we deploy it in parts for some equipment and leave some equipment, so that results cannot be achieved. So first layer is the data acquisition from different equipments. We have installed the external sensors for equipments like the point machine. So for point machine, we are gathering the voltage, current, vibration, and the temperature inside the point machine. And similarly for LED lamp of the wayside signal, we are measuring the current of the signal lamp to predict the health of the lamp. Inside the equipment room, we are monitoring the environment like the temperature and the smoke sensors. For the power supply system, MSDAC for the track detection, and for electronic interlocking, we are gathering the data through their own diagnostic system through the serial interface. So this is the first layer where we acquire all the data and then feed it to the edge device. In edge device, we are integrating the entire data, normalizing it, and then the first layer of the intelligence built in the edge device itself, where we are able to give the local alerts and visualization irrespective of the connectivity with the server. Then this entire data is fed to the server where the predictive analytics is being carried out. Now the second layer is the enterprise asset management. Why the enterprise asset management is very important? Because only creating the alerts is not enough. We have to monitor the work orders created, maintenance work orders created by the alerts, and then keeping track of it by monitoring each maintenance activity on these assets. So enterprise asset management has its own functions of inventory management, site activities, field service, and the asset registry. Then on top of it, the final one is the dashboard. Dashboard is provided for managers to monitor the KPI and the performance of the entire system, where we have given the different kind of dashboards I will explain in the coming slides, which are very useful for monitoring the KPIs like the MTBF, MTTR, etc. Now, if you see the size of the entire deployment, of course, we are covering the 31 stations in 930 kilometers and 135 remote locations where the signaling equipments are kept. In total, there are 150K assets covered under this system, and 70 plus asset classes are created in the asset management system. So we are processing the 100 million plus data points every day. And if you see the number of equipments from where the data is gathered, so close to 13,000 external sensors are provided. Then from interlocking, 30,000 plus internal input-output bits are collected, and 4,000 plus electronic cards of the interlocking are being monitored. 5,000 plus wheel sensors of the track detection system, axle counter. Similarly, there are huge numbers, 1,000 plus point machines where this all vibration and volt current sensors are installed. And this is the size of the deployment. Now we start with the remote monitoring. You see, the benefit of remote condition monitoring, we can see the status of all the equipments at one place. Here you can see in the bottom of the screen, all the subsystems are of that particular station is mentioned. Wherever there is a alert, we can click there and navigate for the further detail to that section. So this is a huge help for the maintenance staff. Without going to the site and the remote unmanned location of the ALH, they can get the alerts first of all, and then before going there, they can analyze the fault sitting in the station itself. Yeah. So next, I will show the few use cases that how the system is able to create the predictive alerts and helping in the optimizing of the availability. So we are monitoring the point machine as I explained already. Then the change in the pattern, operation time or the current, the prediction is possible to be given as a possible fault. Then in addition to the current analysis only, vibration analysis and temperature as well, we are able to create the predictive alert for the point machine. Then the very important, because on the track side we have the wheel sensors of the accelerometer system spread across the length of the track. And we have been able to predict the current drift before it causes the fault. And that has been very useful. Now coming to the power supply system, which is very important for functioning of all the subsystems. More than 20 parameters of the UPS is gathered and continuously monitored. Number one, eliminating the need to travel to the site and then take the measurements as a planned maintenance schedule. All the parameters are available as a remote monitoring system. And the input power supply status, automatic changeover system, and the battery health. Whenever there is an input supply interruption, then battery feeds the power. At that time, we are monitoring the discharge rate of the battery and trying to predict the health of the battery. Now, if we see another benefit of the system that we are able to demonstrate is giving the advanced indication for the failure of the redundant equipment. Because in signaling we have a lot of redundant equipment in interlogging, power supply. So in earlier situation, unless the maintenance engineer visits to the site, he is not able to find out whether redundant equipment is working or not. In this system, as soon as the redundant equipment fails, in this case, what I am displaying here is the AC-DC converter of the power supply. So we'll come to know well in advance before both the converters fails and causes the interruption. Another very important achievement, I will say, is that with the data available, we are able to monitor the number of operation of the point machine, number of operation of the relays, and the number of the hours lit of the LED lamp. Earlier, there is a codal life of the equipment which calls for the time-based replacement of all the systems, including the batteries. Now with the condition monitoring available and number of operations are being counted, this time-based replacement can be moved to the utilization-based or condition-based replacement. Now the integration with the workflow. So very important aspect of the solution. Together with the remote condition monitoring, it is very, very important to track the maintenance work order created by the condition monitoring system as a predictive alert as well as the corrective alert. So both kind of alerts are passed on to the asset management system, and asset management system keeps the registry of all the assets, history of all the maintenance activities carried out on each of the asset, staff planning, rostering, etc., and inventory management. Each work order created on the asset management system is tracked until its closure. Then, as I shown before, on top of condition monitoring and asset management, we have the dashboard which shows at a glance position of all these stations, asset health, and as well as the KPIs like the MTBF, MTTR, open work order, etc. So maintenance staff, maintenance engineers are given with the handheld devices where they can carry out their inspections, fill up the inspections as on the site, can receive the service request on their devices. Now coming to the last part of the paper is the people and culture transformation. As I told in the beginning of the system, the beginning of the presentation is that this is not only the deployment of technology and some digital analytics, but because it deals with the human who are involved in the maintenance activities. So there are significant changes on how our teams carry out the maintenance after deployment of this system. So this change management process is very important to be passed through. And assignment of the work, carrying out the maintenance, etc., changes completely. And this picture you can see, rather than measuring something sitting on the track, which also calls for the downtime of the track. Now the work culture changes to looking at the same data on their handheld devices and interpreting it. So successful delivery of our plans hugely relies on the ability to enthuse and inspire our teams to work with the change and with the technology. Thank you.
Thank you, Mr. Chauhan, for giving insights of the maintenance systems of RMRT, right maintenance, right time, or smart maintenance applied in Western Dedicated Freight Corridor. Thank you very much. From smart signaling maintenance we now move to signaling architecture that makes high capacity freight operations possible. Heavy haul corridors place unique demands on signaling systems, long braking distances, high train density, extended operating hours, and the need for the exceptional system availability required solutions that are often quite different from those used on conventional passenger railways. Our next speaker, Mr. Kaushik Nag, Director of KOSHN India, will discuss the signaling philosophies and design approaches needed to safely support high-capacity freight corridors. Please welcome Mr. Kaushik Nag for his presentation, Signaling Systems for High-Capacity Freight Corridors. Mr. Kaushik, over to you.
Yeah, thank you. Very good morning to all of us, all of the delegates present here. So basically what I try to draw with this my paper, so we just to draw a outline of how the future signaling system can be proposed for our future upcoming dedicated freight corridor. So we are facing basically two challenges. So here we are talking about a axle load of 32 metric ton and above, and with a average speed of 120 kmph per hour with a significant headway. So that three key factors actually I figure it out, and that is factor it out because that is the basis of our design proposal, which we are basically try to understand what is our future needs. So I'll just go to the introduction first part. So I'll just compare quickly with our present system, which is in place with a 2,840 kilometers. So which is basically two signals are placed in automatic block sections. Basically almost all the western corridor are placed in that way, and some part of the eastern corridor. It is a 2 kilometer signal placed at each other at absolute or auto block section, and with a station mean average distance of 40 to 50 kilometers. So while I am talking about the future corridor, so we have to emphasize a new systems which may need to be developed in conjunction with our requirement of the future. So basically my target of to setting this 120 kmph with a significant headway. So my proposal is starting with a design proposal will be mapped to minimum to 4 kmph, so 4 kilometer basically. So that is the spacing of the signaling should be encountered at the auto block sections. So basically the advantage of is that basically say that loco pilot will encounter a lesser number of signals and it will avoid more unhazard situations. At the same time it will be continuous automatic train protection systems which will be in place. So that is our primary set goal. So being said that, so it is a tough challenge, and I am coming to my further slide to how we are try to evaluate this system in a core component levels. So basically what I designated the core component is, one is the direct drive CVI systems, and second one is a centralized traffic control system with TMS deployment. So these are all the core development. So core component, which I'll elaborate in my next slide, few slides. And then advanced coverage. So when I'm talking about advanced coverage, it is having connectivity of lot of other advanced feature, which at present our coverage is lagging behind. So that needs to be developed with our, as a Kyosan also in coverage development stage. So we are also part of that. And similarly, since all the freight corridors is having a basically vacuum connectivity from the first loco to the last loco, so train integrity of the long haul system is always expected. And some of the hot axle detection systems that should be in place. And yesterday I gathered more knowledge of how smart turnout and all those so turnbuckle automatic how it can be monitored. So my sincere request is, so any standalone system may not be in place, so it should be integrated with some action oriented systems. So where signal as a safety indicator, so it can, any system can be proposed from third party, can be integrated with signaling system. So this type of action oriented, like I'm just giving an example, hot axle counter, maybe there is a some occurrence. So out of that, what should be that we have to take the actions. So that is the most primary thing. So that if it is integrated with our coverage systems, so it will be very easy for us to have a corrective actions on that place. And of course the maintenance terminal console, which is an integrated maintenance approach of the all signaling constituent. And basically the last constituent is basically a telecom, so which is a dark fiber network, which throughout the corridor it has to be stretched in. And safety standard, of course, we are as a signaling vendor, we are basically working on the SIL4 principles. So basically constitute of EN 50129 and EN 50716. Basically first one which I spell out, it is for safety, and the second one is for software. Another EN 50159 also there, that is for communications, which is also be in place for the coverage as far as coverage purpose. So I'm moving to my present, this is our today's agenda. So all the component I have placed in. So one by one I'll start to discuss that. So this is a direct drive approach. So why I should go for a direct drive? So basically, so the basic thing is it will be process wise, it will be 2 out of 2 architecture with a hot standby definitely. and that will create a reliability and availability to the greater extent. It is already in place in all the Indian Railway tender also right now, Indian Railway stations also, and plus 300 to 500 millisecond cycle times. So that is one of our key components of our this high speed, heavy haul capacity, because here we may talk about this system frequency time is very important, because next slide we will talk about CTC. When CTC command will be in place, the system response time has to be very precise, and for that purpose that 300 millisecond is a very key factors of the system, so it has to be maintained. So high processing capacity of course there. And the next I just wanted to tell the direct drive approach, where signal, point machine and track circuit through MSDAC can be bundled out in a without relay environment. So this will give a very neat and clean environment of the signaling equipment rooms, which will be basically relayless, which we already deployed various part of the world as a KEOSAN. So, and now it has been deployed in India also. It is under observation from last 2024 November 1st we commissioned. Actually, Kharotia-san was one of the instrumental principal CST at that point of time when we commissioned the first direct drive in India. So that is in Tajpur. So thereafter another 3 stations has been further commissioned. So we are under deployment of another 15 stations of direct drive in place, and 200 plus we are having getting a clearance from the RDSO. So that is a evolving technology, and it is a completely comprehensive, very good for the maintainer. So they need to check about the relay status. So that is one of the things, and key Ethernet communications. So that is also one of the major point of these our systems. So which EI system should possess. So that will give us a flexibility of the data transfer, vital data transfer from with a CTC, as well as for TMS, as well as for another maintenance monitoring systems which may deployed over and above. So this is the critical thing. So of course the no art thing is, it is basically KEOSAN's philosophy of the and it is successfully working in worldwide. I'll move to my second slide. Just I pointed out some of the key advantage of the direct drive, why I chosen for direct drive. Basically first one is the design complexity. If you understood, if we go for a, let us say 250 route to 300 route stations, so interface circuit is almost 700 pages. So to prepare the design, the effort and the manpower, it is a huge constituent of the project level. So this design complexity will be very much reduced. Here interface circuit will be minimal. So only some safety circuit will be there, that will be in place. And all the vital interface circuit will be processed through our direct drive card itself. So that is one of the key constituents. And another is the copper cable reduction. So here I'll just tell you. So here we required a close coordination with our OHE counterpart also. So since the complete section in the DFCCIL is evolved to be as a electrified sections, so we can drop down the auto transformer at the place where the signal is there. Okay, so maybe in auto section it may be 4 kilometer or 5 kilometer. So there is actually integrated approach is very much essentials. So when I am choosing a auto block section, let us say 4 kilometer or 5 kilometer in place, so I am emphasizing 3 things. One is a signaling point of view. Second is our ATP systems tower also to be in place at that location. So I can avoid both in a different way. So signaling coverage as well as the auto transformer of the this OHE can be placed in that place, so that I can avoid complete laying of the power cables from the station to that location, particular location, which is a very heavy amount of copper cables will emphasize, and we can avoid the big scale ALH. We can go for a either by a container kind of requirement or by a prefabricated civil structure to house these kavach and signal gears together there, and from there will be minimum signals, tail cable should be drawn through copper. So this will be a very cost effective solutions as an integrated approach, so we can be think of. And it is already done, some part has been, we did it in Indian Railway, but it is not fully deployed. But and from that particular drive location to our station completely controlled through OFC. So that will be laid through a 48 core redundant fiber with a path diversity that can be ensured in. So I'll just go through that. So another main component of the complexity of the signaling is the MSDAC, how integration took place with the CVI systems. So in this direct drive, it is a completely relayless. It is a CPU to CPU communication. So we will eliminate completely EI IO cards, which is basically constituent for this track input. So there, and this MSDC implementation directly, it is already under in place. We are having some good quality of track record on that, and anyway for the any future new coming MSDC vendor also, we can be handshaking through a Unix interface. So that is our things, and civil structure and space requirement of relay room can be minimized based on the requirement of the signal gears. So anyway, so that distributed architecture to the best extent possible, it can be deployed easily. So basically what I try to figure it out from this, so this deployment can easily very cost effective manner and very time effective manner as project is concerned can be deployed. So my next will be the CTC and TMS. So where I just try to indicate only few slides. So there is I have chalked down this minimum requirement of the TMS, which is already in place with our present TMS train management system. Basically timetable management, display control, display of the yard, track tracking display, and reporting systems. These are all in place at the time in our both the corridor of 2,840 kilometers. But what we are lagging, just if we wanted to deploy this TMS, so this required a server and having an extensive network as well as the different hardware for the TMS purpose. With the same hardware, so we can able to deploy the CTC. So that should be an added advantage to the as far as operating point of view. So centralized traffic control, it is having a various features. So you can opt it for this for our future corridor as a this is our basically suggestion from the industries. So it will be make your life very easy, but there is some misconception about the manpower cutting took place in different forum which I have discussed this, but that is not the correct things. So these also needs manpower. So basically it will make your operation very easy, and for the long haul operation of the tenure of 2,000 kilometer plus section, it will be very effective. It can be placed in a section wise basis also with a already, and it can be overlaid with the existing TMS system also. So with a very easy system, so it can be control that. I'll just sum up the feature of the CTC system and train management system I just put in place. So here basically if you see that first slide, it was a long route setting. So here, just a minute, I'll just back the slide. This is basically ARS, which is the automatic route setting, where timetable already in place in our TMS. So over and above, we have to added this feature in the CTC so that ARS can be deployed. And since DFCCIL, all that trains are maximum, we will try to put it into the timetable format, timetable driven, so ARS can be easily deployed. It is challenge in the mainline sections, although it can be overcome through a systematic deployment of timetable. And next one is basically the long route setting. So it is having a unique feature. We can set the route from first section to the last another few sections. So with this CTC system, I'll just go through the quickly because I am having bigger slide. This is all the things. Another, just I wanted to see some, this is a train tracking and train describer system. It is already in place. This is a train management systems. So just I'll go to the little bit ahead. So the next our Kavach. So this Kavach, I just wanted to have this is the architecture of the Kavach, which is a Indian Railway ATP. Basically it is worked on a UHF at present, but it can be future compatible with a LT backbone, as well as this can, and it is a basically track tracking will be done through RFID. So that is the additional deployment over and above MSDAC, which will be make our life more secure and safe for the complete deployment. And here I just wanted to keywords which I highlighted in the red color. Enhancing the braking capacity. Actually, the locomotive is today also running in ATP mode, basically if it is a Kavach deployed, which is not mandatory whether it is a basically driver driven, although over there is a overlay of ATP is there. But if I approach little bit ahead, so of ATO, automatic train operation, so this including costing and cruising and stopping accuracy can be achieved with very easy over and above the ATP system which Kavach at present is having. And of course, we are recommending for the LT or 5G based for the next generation Kavach. And another thing, the third point is very vital. It is a virtual signal. So when I am talking about 4 kilometer or 5 kilometers signal apart, so we can be think of the virtual signal also when our ATP is in place. So it can be only visible to the driver signaling cab. Physically, signal will be not there. Okay, so this virtual concept mixed with the actual signals, more we can reduce the signal actual deployment at site. So this will be a unique idea for the freight corridor where maintenance of the signals may be future. It is a very tough task because it is the section is anyway very long section for maintainer. So this type of already this virtual signal concept, it is nothing new on that. It is metro, it is very much there. So we just wanted to have this approach in our Kavach deployment. So I'll just go through that. So sorry, I just finished that, and some more slide of that. I just there is another thing as I told already in place, that is a train integrity monitoring system. So shall I continue? It's two, three slide. I'll just show the key slide. So here basically what we are trying to do is the locomotive, all the wagon will be connected through a electronics with a BLE 5.3 or maybe more advanced system. It will be integrated with the locomotive as well as crease system, so that wagon management system can be in place through these systems. So another things, as I told you, hot axle counter. So the main point is you can deploy anywhere in this system, any advanced system you can be deploy, but it should be integrated with the signaling system. So with that I'll just try to finish my slide because it is too much. Anyway, so this is our few achievement which we have did it at Western Corridor as well as so with that I just try to have a conclusion. Thank you. Sorry for the bigger slides. Yeah. So.
Thank you, Mr. Kaushik, for sharing roadmap for signaling for future freight corridors. As dedicated freight corridors mature, the challenge gradually shifts from construction to stewardship. The question is no longer how to build world-class infrastructure, but how to maintain it reliably over decades of operation. This challenge becomes particularly important for signaling and telecommunication systems, where reliability directly influences both safety and network capacity. Our next speaker brings extensive experience from Indian Railways and will discuss infrastructure maintenance strategies specifically relevant to dedicated freight corridors and high availability railway system. Please welcome Sri G.K. Dwivedi from Carnex Microsystems. His presentation is titled Infrastructure Maintenance Strategy for Dedicated Freight Corridors in India. Mr. Dwivedi, over to you, please.
Thank you. Good morning, ladies and gentlemen. Since yesterday, we are hearing the components-based focus. Somebody is discussing the track, somebody is discussing the rolling stock, somebody is discussing the signaling system. But we have to see we have seen the elephant in the room. Only thing is that our perspective is different. Somebody is looking at its eyes, somebody is looking at its trunk, somebody is looking at its legs. But I would like to give a perspective of looking the elephant as a whole. In fact, as a career S&T engineer for Indian Railways, I have been working for the project as well as the maintenance both. I know the pain points of the maintenance. So we have to basically look from the perspective of this dedicated freight corridor, although we call it dedicated freight corridor, but the operation is altogether different from other freight corridors worldwide, because it has been built with the improved parameters, means higher speed potential, higher axle loads, but its integration with the Indian railway system, because it is not originating traffic is also on the Indian railway system, terminating traffic is also on the Indian railway system. So even though we have the improved and high parameters for the dedicated freight corridor, but still we are unable to utilize these parameters and features truly because of this integration with the Indian railway system, which is having the different parameters. So in addition to that, as already by this time everybody is knowing that stations are 30 to 40 kilometers apart, signals are located at 2 kilometer distance, automatic signaling huts are there at every 3-4 kilometers. So like that way assets are spread over, accessibility is the main issue. So we cannot adopt the legacy periodic maintenance system or reactive maintenance system of Indian Railways over dedicated freight corridor. So what is the solution? And if we are failing in implementing these solutions in time, then our all advantage of getting higher speed, higher axle load over the dedicated freight corridor is going to be lost in case of any human slippage in the maintenance, any maintenance schedule missing, or not attending the system or redundant system in time. So in that case, we have to adopt a altogether different strategy from the Indian Railways legacy system, legacy maintenance system. And we know that if we are going to have the derailment, if we are going to have the major failures, it is going to eat away the capacity. And for that purpose, we have already seen that a good amount of condition monitoring systems has been deployed, but we have to achieve the advantage of all these deployed systems in such a manner so that we can optimize the operation, we can maintain the highest average speed over the dedicated freight corridor. So this vision of segregation was basically to separate this freight corridor was to free the capacity for Indian Railways, number one, and number two, get the better parameters on which our freight trains can run safely. So I call it a technical divorce between the Indian Railways and dedicated freight corridor. It is not a real divorce because Indian Railways is having the mixed traffic model where our Vande Bharat as well as heavy coal and iron rakes share the same oxygen, same track, same infrastructure, and freight trains are looped or delayed to give the precedence to passenger trains on the Indian Railway network. And that's why the average speed is still 15 to 30 kmph. Whereas dedicated freight corridor is reserved strictly for the cargo movement, no passenger interference, and it is allowing the speeds of the train to as per the scheduled timetable with 100 kmph speed potential and 2 into 25 kV specialized high rise OHE, which is supporting the heavy loads. And there are some hard numbers which I am going to share with you just to compare the operation, just to compare the Indian Railways as well as dedicated freight corridor. There the axle load is 20 to 25 ton in case of Indian Railways. Our rolling stock, our freight trains are coming from that system and they are entering to the system where the axle load is designed for 32.5 ton but permitted up to, operationally permitted up to 25 ton because it is limiting due to the Indian Railways restrictions. Moving width is also higher. Moving dimensions are also better and train load capacity is almost doubled. But are we able to utilize this full potential of this dedicated freight corridor? We have to see this. Again, as our inter-signal distance is 2 km, we are able to effectively manage the longer haul trains, means in case of Indian Railways, if it is 700 meter length, here we are able to manage 1500 meter length train, and this gross trailing load is going up to 15,000 tons. Double stack containers are possible to run on the western dedicated freight corridor, and high horsepower locos are pulling these heavy loads. All these improvements has given substantial improvement in the transit time by about 50%. Yesterday it was already mentioned that how the transit time between in the eastern dedicated freight corridor and western freight corridor has reduced to almost 50%. Now, with these improvements, we have been able to achieve almost 120 GMT per annum, which is unmatched scale. Indian Railway cannot imagine this scale of operation. So, just to support this level of traffic, we cannot adopt the traditional method of periodic maintenance and reactive maintenance. Now I am coming to the challenges, although we have seen the challenges in track, rolling stock, signaling systems. But just to recap the things, I am just listing it out. I am not going into detail because I am trying to look from the system perspective. So this continuous 25 ton axle loads, they are leading to rails to extreme cyclic loading and multiplying internal micro cracks and sudden rail fractures. These are going to be the result of this operation. This flash butt and aluminum thermic welds, they degrade exponentially under this DFC tonnage compared to Indian Railway main line. The block paradox, because the trains are timetable here, we want to utilize the maximum capacity. So the traditional mechanized stamping, the traffic blocks required for maintenance of the assets on a periodic basis is just not feasible, because there has to be a compromise. Then again, this yesterday we have already seen this white spots on the tracks, and this dynamic crushing factor is the basically result of this heavy axle load and higher speeds. So what is the solution? Solution yesterday already we have already seen this one. This real-time track geometry measurement system is the solution, and ground penetrating radars to monitor the track structure. Then again, there are thousands of bridges along the track, and they are sustaining massive trailing load density of 12 tons per meter. This is much more than conventional Indian Railway system. So what we have to see, we have to keep our eyes over the bridges, what are they saying? And for that purpose, this structural health monitoring system for the bridges is also equally important, because physically it is just impossible to visit the bridges and physically inspect the bridges. So there are some solutions already available, and it is known because I am not expert in that area, but we have already heard the experts since yesterday. Then again, this is spatial spacing dilemma. See, IR stations are 6 to 7 kilometers on the average apart, whereas in case of DFCC it is 30 to 40 kilometers. Signaling huts are almost 3 kilometers apart. In case of Indian Railways, this is not the scenario. They are on a continuous basis. Almost every 1 kilometer we are having one or the other assets. So this spatial spacing available on the freight corridor is having the risk of high MTTR. Means the person has to reach from one section, one place to another place. Accessibility is the issue. Time travel is more. So in that, it is going to have the risk of high MTTR. Then again, this, in case of Western Dedicated Freight Corridor, although we have adopted the high-rise OHE, but it is having another significant risk of pantograph, when the pantograph is hitting the height, and it can create severe wave propagation in the OHE. And there is a devirement effect threat available in this system. Then again, this due to the higher trailing loads, there is a thermal tax on the OHE. Current draw is high due to high traction load, extreme currents, and there are thermal spots which are thermal stress which are going to be created in the system at the junctions. So these are some of the factors which are basically associated with this adoption of this technology, and we have to get over with that. Now the signaling, because we cannot discuss the things in isolation, track, rolling stock, OHE, signaling. Although it is a silent guardian, because when everything is available, the trains cannot run at the maximum potential, speed potential, unless the signaling permits this. And it is available. So for that purpose, freight corridor DFC is adopting this coverage system, which is the IRATP, indigenously developed over its network, which is going to have the protection against the human error, but the integrity of the signaling system is required to be maintained in spite of that. Then we have already heard our friends from Hitachi and Kyosen. Remote condition monitoring of the signaling assets is already in place. Only thing is that it should not become a burden on the maintenance system, because every additional equipment is going to create a maintenance burden. Then we have already seen this electronic interlocking is adopted over the network, and it has been networked. They are able to monitor from the central point of view. So in this way, signaling is contributed to this capacity utilization of the freight corridor. Then this continuous handling of massive loads at 100 kmph is leading to this wheel flattening and shelling. There are coupler stresses also because of the higher speed when the CBC coupler are facing this due to undulating terrain and higher speed. It is having the extreme strain on this coupler also. Then again, we have basically in the Indian Railways, we are running the 700 meters long trains. Here in the DFC corridor, we are basically attaching the two trains together. We have named as Anaconda and Vasukis as their name, longer trains. And they are creating basically terrible tensile stress on the couplers. And this long haul rakes are negotiating the undulating gradients. Again, it is going to create a stress on that. So maintaining this kind of system is just like a marathon runner is running and we are trying to measure its pulse. So you can just imagine that how challenging it is. And as far as vulnerabilities are concerned, it is already known to everybody, and plus moreover, it is DFCC is also facing the same kind of failures and vulnerabilities, like in rolling stock, flat wagons, bearings, hanging parts, permanent way, weld failures, fissures, and alignment shifts. Power and traction I have already discussed, thermal stress and occasional trippings, signal and communications. So, what is the solution? Since freight corridor does not have any control on the rolling stock maintenance, so they have to create a rolling hospitals just before the rolling stock or freight train enters into their system from the Indian Railway system. So wayside diagnostic and inspecting trains at full line speed is required, and screening the rolling stock at entry points is required. Wayside diagnostic arrays, yesterday we have already heard this ABD, WILD and MBIS has been deployed over the system, but now the question is how we are going to take the advantage of these deployments. So this again, all these symptoms, what data and everything is getting generated, but how to utilize this data so that we can take a decision in time for adopting this predictive maintenance from corrective. So the ultimate defense is that we have to converge all these data generated by these sensors, monitoring systems along the track at the specific locations, and it is required to be analyzed so that a consolidated decision can be taken, holistic decisions can be taken to optimize the operation. And for this purpose, we have already seen that digital twins in the world, which has been coined, and it is in realistic phase now. At various places, I'm just going to showcase those kind of things. So by this time, you are already aware that what is this digital twin means. It is a virtual representation of the physical assets updated in real time with IoT, telemetry, and allowing engineers to track the remaining useful life of the assets. For this purpose, just I want to give the confidence to the audience here that it is not that we are just starting this discussion now. In fact, UK Department for Transport has already constituted the study. They took the vision document in 2021 for this digital twinning of the entire infrastructure. And in 2024, they published a study after 1.5 years of a study. And this study has given the monetized value of the benefits, what is going to be achieved over next 10 years. And this is a well documented report available in the public domain, which decision makers can go through. So in case of planned works and maintenance, it is going to give about the over-the-air network 528.3 million pounds advantage. I just want to narrate some success stories because I have gone through, I have seen the Austria, I have seen the Germany, and network I have not seen, but digital twin has been adopted in their 3 lines, London Underground, Transpine route upgrade. In OBB, for example, has created the complete digital twin of their entire 7,800 network, 800 route kilometer network. Similarly, this Germany has also digital twin explorer they have already created. It is going in a big way. Yesterday we have heard the Siemens gentleman, and Germany basically they have created a data factory. I will not go through the detail. The slides can be seen.
Sir, please conclude.
Yeah. Similarly, this CONEX in Germany has already conducted a study, and on the point and crossings, that point and crossing defects can be very well predicted 28 days in advance. So the way forward for DFCCIL is convergence is the only solution. Whatever system we have already deployed, we have to converge the data created by those, analyze it, and then focus on the condition based monitoring, and then this, after doing this one, we will be able to achieve the exponential growth what we are planning for carrying the freight traffic over the freight corridor. Thank you so much.
Thank you, Mr. Dwivedi. Thank you all our presenters. We have received large number of questions. I will 7 questions from Sri Chauhan and 11 questions for Sri Kaushik Nag. I request Sri Chauhan to take up their questions, keeping in the mind the time available.
Yeah, I will club several questions because it may be of similar nature. So one question is about whether the condition monitoring system for signaling that I explained, whether it covers the rail fracture. No, it does not cover the rail fracture, but of course it covers the point machine health monitoring. And one question is about that large volume of cable can be reduced using the microchips. So I don't think microchips can replace the cables, but definitely the direct drive systems will reduce the copper cable up to great extent, and instead the fiber cables will be used. SSD and back drive both used in WDFC. I know SSD is used, and of course the back drive would be better than SSD for the function of the turnout. And one is about the Hitachi deployment smart maintenance in metro. Yes, of course. For the metro, one of the example I can give you the Copenhagen metro, where we have deployed this system, and it was on the Hitachi system only, because the second part of the question says the other make of the signaling. In this case, Copenhagen case, signaling was from Hitachi. And one question is about the cold standby. Cold standby system, if it is not powered on, we cannot monitor its condition, and it need to be checked by visiting the site and in-person inspections. And the frequency of monitoring in our case is, for most of the equipment, it is 1 minute. We are updating the status data every 1 minute. How predictive maintenance is helpful in predicting failure? MSDSE, yes, we have integrated the MSDSE health monitoring as well. And as I shown that current drift, we are able to predict. And I believe and I trust that with more data gathered and our models are trained over a period of time, we'll be able to detect many more failures of the axle counter. And one is about the remote monitoring is not exactly the digital twin, but for many of the equipments, we have tried to show the graphical representation, but I cannot say that it is a digital twin. Yeah. So, oh, sorry.
Thank you, Mr. Chauhan. Now, to Mr. Nag.
So I'll just start. I group together whatever is a similar nature of questions. So basically, most of the people are asked if I make from 2 to 4 kilometer, if line capacity will be reduced or not. So this is not the true perspective, because when I'm talking about a 2 to 4 kilometer or maybe 6 kilometers, so basically keep in mind there will be a continuous ATP system in place. So there will be a continuous monitoring. So the train will be apart from a headway. It can be predefined, like metro it is working. So it is not advanced as metro, but it can be, Kabach can be deployed in that manner. So actually what I try to basically chalk out is the signal, it is not exactly 4 kilometer, it may be more than that also, based on the ATP, IRATP Kabach location tower. So basically I wanted to, anyway there will be a wayside ATP. So wayside ATP signals to be clubbed together maybe 5 to 6 kilometer apart, where LTE tower also will come. So in that way we can reduce that complete signaling almost more than 2 times. So that will not affect any of the line capacity enhancement process. So it will be more dynamic will be the our nature, because that all the train are fitted with the ATP. So the train can be pushed through the and without any operational interventions. So the train to train, they can be monitored and it can be pushed through, so with a safe distance margin. So there is no significant A of that. So with that, actually another question, what is the reduction of the overall cost? Similar system. Of course, it is a long time cost, will be much reduction of, as I already mentioned in the direct drive implementation, the copper component. But provided when we are talking about copper saving, we must consider of the utilization of the OHE system effectively, so that auto transformer can be placed in same location where signaling hearts are there, so that signaling power cable should not be draw from the stations. So that is the questions which I just wanted to answer it. And the second one is one person has told that 300 to 500 millisecond, how it can be achieved. So it has to be inbuilt in the hardware as well as software design concept. In Kyosan it is very much there. So I think so almost all worldwide, all the Siemens, Alstom, everybody having fulfilling this criteria. So it is a design perspective of the EI systems, so no need to worry about, that is already in place. So only we need to consider when it is a big yard, when the route is more than 800 plus, so how we can maintain that 300, 500 to 500 second effectively. So second is the two similar, another kind of question is MSDSE, how actually some of the track track people find it difficult to maintain track maintenance due to the deployment of the MSDC axle counter. It is a true problem. It is actually problem is there. So only solution of this is basically it is CBTC based track solutions, but that is it may be not appropriate for this kind of long haul systems where we are talking about a maintenance free. So anyway, if that let us say we go for a CBTC mode to avoid this DP, but in that case if DP connection has if this air connectivity has been lost, in that case train will be stopping. So in that time we need to again have required a fallback system. So system become more complicated. So CBTC system along with a fallback system is the correct solution. It is already there in place for the metro system, but for deployment is 2,600 kilometers like this type of stretch, it will be costlier effect. So this is the things. And another few question is what is the media used between the central EI to end of the EI? So it is basically from the central logic to the auto section block, it will be OFC. From OFC to the signals, it will be a copper cable. So as on today, so at the end field gear, redundancy of the interface drive until is certain. Actually, when we are talking about redundancy, we have to be very careful of the end solution. So end solution is a signal 1 LED. So if you put a 3 redundancy or 4 redundancy, that doesn't make if one LED fail, all the redundancy will be fail. So you can think of all redundancy level, but it will be system become more heavy, and it become basically OEM will enjoy the benefit. Basically we are having no problem to having a redundancy, super redundancy, achieving that, but you have to understood our end of the signaling gear like a point signals, all are individuals. So if that signals one green LED fail means no other way it can be run in. So that is the simple way. So that I just say that. And actually long route setting also he asked for CTC. Actually long route setting, it can be from let us say 1 to 5th station I required a continuous straight passenger freight running every day. So I can put a single route on that, and it can placed in a long route setting manner. And further there is another options. If you want this operation regularly, you can use the stack operation. You can put that operation, perform that operation and stack it in your store box. So when you require this operation, you just click one, it will be route will be set like that. That is a route stacking, another feature of CTC. So it is not only long route can be stacked also in that manner. So it is a very effective.
Time is very limited.
Sorry. So
we are exceeding time. So
yeah, so
during the tea we can continue with these questions and answers.
Yeah, thank you.
So if few questions can be answered by Mr. Dwivedi, please.
I think one question is really interesting from Professor Ravi that I would like to answer quickly. What is your suggestions and recommendations to continuously monitor special expensive railway infrastructure such as bridges, turnouts and ballast in the DFCCIL? Manual inspection and track geometry measurements using dedicated equipment is not sufficient to improve the resilience of this important infrastructure. This is very interesting questions, and yesterday we have seen in one of the presentation that there is no need to copy the solution which has already been implemented by any system. We have to adopt it as per our requirements. Our requirements here, yes, it is a scale, and plus moreover the capital cost. So for that purpose, we can adopt not only the fixed measurement system, we can adopt the moving measurements and diagnostic system also. We can adopt the concept of Dr. Yellow train, which is already in operation in the Japan. They are running this full diagnostic train across the routes at unscheduled intervals, and they are able to diagnose the entire system, tracks, bridges, signaling system, OHE, every parameter. They are able to do that one. get the diagnostic reports from that and accordingly generate the work orders for attending the particular infrastructure which is in. So I am not recommending that we should put the sensors or SHM at every bridge and every culverts. No, it is not feasible. But till such time it is done, we have to adopt solution which can be implemented and the advantage can be taken in a progressive manner. So this is, I think we can think over. For example, last year, I remember that Indian Railways has already adopted this USFD testing, self-propelled USFD testing vehicles at the higher speed. Till now, we were doing it manually on the walking speed. Now it has been escalated. So in the similar way, we can adopt this Dr. Yellow Train model, which we can discuss in detail. I think I'm closing this.
Thank you, sir. Thank you all presenters. Back to Ms. Joey, please.
Thank you very much. Ladies and gentlemen, we have just concluded the first part of our session. We will have other distinguished experts as well who will be sharing their perspectives and experiences in the second part of the session following the tea break. But before we proceed for our break, I would like to remind everyone that all registered delegates are automatically entered into the DFCCIL lucky draw. We have 10 grand and exciting prizes to be won this evening. So there's a very special note. Winners must be present in the hall to claim their prize. I repeat, the winners must be present in the hall to claim their prize. Thank you. So we see you in 10 minutes. We reconvene at 11:25. Thank you very much. Also, a few of the mobile phones were ringing during the speeches of our esteemed experts. May I please request everyone to put your phones on the silent mode to maintain the decorum and sanctity of this seminar, and also requesting the moderator, Mr. Kailash Khirotia, to kindly please re-begin the proceedings, sir.
Thank you, Ms. Jui. Welcome back for next part of our session. This morning first session focused on architecture of modern railway control system and the maintenance framework required to support them. In this next session, we move closer to the operation railway itself, examining how data, electrification systems and train protection technologies are being used to improve reliability, reduce maintenance burdens and enhance safety across high-capacity freight corridors. Across the world, railways are seeking to move from periodic maintenance inspections towards continuous asset awareness. The convergence of IoT sensors, cloud computing, and artificial intelligence is making it increasingly possible to predict failures before they occur and intervene only when necessary. For freight railways operating at scale, this represents one of the most important maintenance transformations of the modern era. Our next speaker, Mr. Shubham Khatua from Webtech Corporation, will discuss how these technologies are being applied to traction assets and maintenance systems. His presentation is titled Emerging Trends for Use of IoT and AI for Predictive Maintenance of Traction Installations. Over to you, Mr. Shubham.
Good morning, everyone. Thank you, Kailash ji, for that kind introduction. It is an honor to be a part of this seminar and to have the opportunity to present before you today. Railways are the backbone of India's economic growth, connecting industries, supply chain, and people across the country. In such a system, even a single locomotive failure can create consequences far beyond a train delay. On a dedicated freight corridor, a single stalled train can trigger ripple effect on the entire logistics network. When thousands of tons of load is moving at 100 kilometers per hour speed, response time is measured in seconds and the cost of downtime can be enormous. Today, I want to talk about some of the emerging technologies in the field of predictive maintenance of traction installations. Today, rail operations must address three persistent challenges at the same time: safety risk, network congestion, and maintenance inefficiencies. Solving these challenges at scale requires more than a traditional monitoring. It requires a connected ecosystem where the Internet of Things enables real-time data collection, while machine learning and artificial intelligence transform these signals into actionable insights. To understand how this happens in practice, it is useful to look about how maintenance itself has evolved. Reactive maintenance means reacting to a failure after the issue has already occurred in field. Initially, it may look inexpensive, but over time the number of failures increase and the downtime increases proportionally. To solve this problem, predictive maintenance partially tries to solve the problem using scheduled servicing. The number of failures reduces because of scheduled servicing, but the initial cost is very high. To achieve the right balance, the fields are increasingly moving towards predictive maintenance. Predictive maintenance combines the onboard edge compute and the offboard advanced analytics to predict failure before they happen, enabling better reliability and lower lifecycle cost out. Okay. So the predictive maintenance means prediction of a specific issue and following instructions in the service shop that are customized for that specific issue and that specific locomotive. This can be achieved by a 6-step strategic process which we call remote monitoring and diagnostics. First, the onboard control system creates the data log on the locomotive. These logs are transferred either through manual downloads or through real time using cell modems to a centralized server. A set of rule engines continuously work on these data, collected data, and machine learning models pinpoint defects. Once the defects are created, an expert looks at all those defects and writes customized troubleshooting steps which are specific to that defect. A final layer is added by tuning the customization steps for the environment and the operating conditions. Finally, once the locomotive arrives at the shop, the service crew follows the steps, and the feedback collected during the servicing helps again retuning the rule engines so that we can improve the accuracy over time. All of these steps anticipate failures, cut downtime, and lift the fleet-wide productivity. At Wabtec, we use a single integrated platform to provide the end-to-end remote monitoring and diagnostics, which we call Wabtec One. So consider there are multiple trains traveling at different locations. They transfer real-time data using the cell modem, which is collected into a single source or place. So an advanced analytics engine runs on this data, where the locomotive's data is compared not only with its history or historical trends, but also it is compared with all the other locomotives of the same design in the fleet, so that failure patterns can be visible. All of this helps in train scheduling, improving safety, reducing the downtime due to shop operations, prompt response, and predictive maintenance, increasing the overall performance of the rail operation. Now, let's look through some of the latest trends on the onboard installation for condition monitoring. The first example that I would like to talk about is the drivetrain health monitoring system. The wheel and the traction motor combo set provides the motive force to drive a train. One of the major components of the traction motor is the traction motor bearing. The health of the bearing depends upon the lube oil which is used to protect the bearings. Over time, the lube oil quality degrades and the bearing is prone to failure, which can lead to locked axle kind of condition. Recent sensor technologies like the gear case oil level sensor and the temperature sensor helps predict these kind of failures ahead of time. So a system can be designed where the weight, the tractive effort, the wheel diameter, the locomotive speed, throttle, and brake conditions are taken as input, and the oil temperature and oil utilization over time is predicted. Now, these predicted values are compared with the actual values from the sensors, and whenever the deviation is more than a specific threshold, a flag can be raised so that necessary servicing can be done on the locomotive. Second example that I would like to talk about is the axle box vibration monitoring. Excessive vibration on the wheels cut traction and it fatigues the bearing, which may lead to risk of derailment. The axle box accelerometers, which are capable of capturing the lateral and vertical acceleration or the vibration on the axle box, helps detect these kind of failures. The GPS location, track curvature, speed, throttle, and torque are taken as an input, and for these specific parameters, the actual lateral and vertical vibrations are measured. Now, this vibration signatures are compared with other locomotives of the fleet which have gone through the same track. And whenever the deviation exceeds the threshold, a flag is raised for the maintenance to look over it. The third example here that I would like to talk about is the pantograph health monitoring. There is a carbon strip on the pantograph which transfers electrical power to the propulsion system of the locomotive. Wabtec Smart Carbon is basically a sensor-equipped carbon strip on the pantograph head, which has various types of accelerometers, temperature, and humidity sensors, which is capable of detecting the degradation of the carbon strip over time, preventing like loss of traction on the locomotive. Okay. Moving further, I would like to talk about some of the latest trends on the wayside installation system for condition monitoring. The recent trends have been focusing on automatic non-contact data collection. Today, I would like to talk about 3 different kinds of sensing technologies that are used to provide below deck condition monitoring. The first one is the vibration or acoustic based detection. We know that the bearing health of traction motor is important to prevent catastrophic failures and derailment. The acoustic based signatures on the bearing provides like identifies issues before the thermal or visual symptoms even appear on the bearing. So the signature of the acoustics that is captured by the sensors is compared with the healthy bearing signatures, and whenever the deviation is more, a flag is raised. Next, I would like to talk about some of the vision-based technologies. Recent advancement in high-definition cameras have improved or accelerated the research on this front. This eliminates manual inspection of wheels and below-deck components, improving speed and coverage. So with the vision-based technologies, we can detect structural and surface defects across the rolling stock. Some of the Waptec systems like tread view, wheel view, brake view, and train view helps provide the holistic view for how to detect the preventively detect the failures that can happen on the wheels, identifying issues like wheel flats, cracks, wear, or brake issues. The third thing that I want to talk about is the thermal-based detection. This is specifically used for detecting failures on the bearings, brakes, and motors. For the bearings, the thermal-based detection tries to detect the hot spots before they even occur, and it can be like a trend-based approach can be used for detecting the hot bearings before ahead of failure. For the brakes, excessive frictions can be detected using the thermal-based images, and for the traction motors, electric flashing or any kind of electrical failure which has like a temperature-based signature can be detected ahead of time. Another innovation that I would like to talk about today is based upon advanced vision technologies called Rail Ghost. Rail Ghost is a robotic sled that can maneuver on the rails below a stationary rolling stock. This directly improves the labor productivity because it saves times during the inbound and outbound inspection, automating the whole process. It also helps in identifying the brake hose lacing issues. This overall increases the yard throughput and enhances safety by reducing the human intervention in the yards. Overall, this elevates or helps in on-time train departures. So as I close, consider this. The locomotives of tomorrow will not only simply run on rails, they will run on insights. Every vibration sensed, every thermal anomaly flagged, and every pattern learned by the models bring us closer to a future where breakdowns are anticipated rather than endured. In this essence, this is about engineering reliability at scale, turning data into foresights, and foresights into consistent system-wide performance across every locomotive, every corridor, and every journey. That's how we achieve a more reliable and safe rail network. Thank you.
Thank you, Mr. Soham, for giving us 3 minutes margin at least. You have beautifully covered that the future of reliability engineering undoubtedly lies in effective use of data analytics and predictive intelligence. We move further now. Heavy haul reliability is often determined not by the largest assets, but by the smallest. Neutral sections occupy only a tiny proportion of railway corridor, yet a failure at one of these locations can have significant operational consequences. Their design, reliability, and maintainability are therefore critical to the performance of electrified freight corridors. Our next speaker, Mr. Amitabh Ghosh from Arthur Fleury, Switzerland, will discuss the role of neutral sections and section insulators within demanding heavy haul environments. His presentation is titled Neutral Section and Section Insulator for Heavy Haul Application. Mr. Ghosh, the floor is yours.
Thank you, sir, for the nice introduction. Good morning, ladies and gentlemen. To start with, I will give a brief introduction of our company, Arthur Fleury. So we are a 106 years old company based in Deitingen. It's a small village in northern Switzerland. And we are a leading global provider of designing and manufacturing quality components for railways overhead line equipments like short neutral section, section insulators, different OHE fittings, including current carrying droppers, different clamps, rail earth clamps, etc. And our products are in use in different public transport systems in more than 40 countries, including India. So our journey in India, so if you see the picture on the right top corner of my slide, we are still at the same location in Deitingen. So we are in total 120 people worldwide, and the turnover of our company is more than 50 million Swiss francs, and our export share is more than 80%. In terms of our worldwide presence, we have our subsidiaries in Italy and in UK. And in 2022, we have established our 100% owned subsidiary in India at IMT Manesar. And this subsidiary is a bit special than our other subsidiaries, because our other subsidiaries are mainly the sales office and sales operation what we conduct there. But in India, we have the capacity and capability to do certain assemblies of our products in India. So we are doing the final assembly of short neutral section and section insulators in India. And apart from that, last year we started doing the final assembly of current carrying droppers in India. And we have supplied our droppers to different metro operators in India. And we are also working very closely with Indian Railways and DFCCIL. I think this slide speaks a lot, because our journey in India started back in early 1990s. So the picture what you could see on the left side of this slide is from 1993, when then CEO of Arthur Fleury Switzerland, Mr. Adrian Fleury, he was presenting the short neutral section at Varoda House, the headquarters of Northern Railway. So I see it is very special because our association with India and Indian Railways, it's a long journey. And the picture what you see on the right side of this slide is our subsidiary at IMT Manesar. So as of date, we have supplied more than 4,500 neutral sections in India, including Indian Railways network, DFCCIL, different metro operators. And I'm proud to say that as of date, we do not have even one design failure. And as Sir said, though the neutral section looks a simple component, but its functionality is very critical in running a reliable network. So as we have been discussing about reliability yesterday and today, my presentation will focus how a very small component on OHE can help and contribute to maintain a reliable network. So, and how we could bring our reliable know-how to this. So as Earther-Fluorine, the products are designed since more than 100 years, some of the components. We have more than 100,000 section insulators and 10,000 neutral sections installed worldwide, out of which more than 4,500 installations are in India. Use of high quality material, because this plays a very critical role, with low life cycle cost. I think I will go in details in my upcoming slides, and on-time delivery and repeat support. Earther-Fluorine still believes in all-in-one house philosophy, because what we have seen in last years, companies, they are becoming more integrators, but we as Earther-Fluorine, we believe in all in-house philosophy. So starting from development, engineering, tool manufacturing, purchasing, production, sales, after-sales support, we do it in-house as Earther-Fluorine. As of date, all our production are done back in Switzerland, and only Earther-Fluorine India has the capacity to do certain assemblies in India in order to respect Make in India compliances. So talking about the reliability and to have a reliable solution, and when we talk about from a component level, a very small component level on OHA, what we believe minimizing downtime and to have a longer maintenance interval plays a very crucial role. Because if we could have a lower downtime, minimize the downtime and can have longer intervals, that space we could utilize to do some other activities more constructive. So we believe that product with low life cycle cost are built to last, because they would avoid risk and failures in the network. They would increase the overall affordability for the operators. And of course, this would also result in reduced labor spare part requirements. As Earther-Fluorine, we work very closely with operators to support them, how they could have such calculations, how they could better understand what kind of impact they have in reference to having a lower downtime, and also to have a larger maintenance interval. So this is an exercise what we are following and conducting with different customers, and also in India we have been doing this exercise with different operators and also with DFCCIL. And of course we follow all the relevant standards. Now, again, talking about the reliability, as Earther-Fluorine, we believe the production process is very critical, because what we have seen, a product with inferior quality can cost you more in intervention in comparison to the cost or the piece price of the product. I think that's where we as Earther-Fluorine, we focus on the production process. And our production process, we follow the cold forming process. Here we have better performance of the product, what we can gain from such a process, and it also offers a very smooth surface, because to have a smoother surface, that would also play a vital role, in our case, the panto passage, and thereby increasing the life cycle of the product. Now, coming back to the raw material, I think that's another very critical part, what we believe plays a very crucial role. And we at Earther-Fluorine, most of our components are made of Kunisi. That's a copper alloy, copper nickel silicon, because this alloy provides hardness and tensile strength like steel. And of course, it's lightweight, so that's very important and crucial on an OHE application. And then it has a very good electrical conductivity, comparable to copper, and suitable for harsh environment. This, in India, we have certain references, we made some certain test case, and there we got a very positive result. And finally, high savings due to low life cycle cost. I would now like to focus on our product, and the first product what I will talk about is our section insulators. Section insulators and neutral sections are key, and these are in operations on OHE lines for many decades. And also coming back to DFCC, we have been our products installed in your network, both section insulators and neutral sections. I believe most of you would know this. This is our standard neutral section, what we have offered worldwide. Of course, if I go to my previous slide, we have different solutions depending upon the speed requirement. We have solutions for 160 kmph, then we have HS25, which is for 200 kmph, and finally we have the new generation product, HI25. It's very interesting also for heavy haul operations. I will go in details in my upcoming slide, mainly on HI25. This conventional LWSI, what we have been offering worldwide, is also in use in India. So it's applicable for speed potential of up to 200 kmph. We have more than 30-35 years of field experience. It's made of, the insulators are with PTFE, suitable for heavy polluted areas, and rotable insulators rods. And the service life of our insulator rods are up to 2 million pentopassage. I would like to show you a use case of our LWSI in India. This is another example of our LWSI. It's in Bangkok Red Line. Because what we see that sometimes if there are issues with the movement of pantos, and if they are the installation, then there could be certain downtime, and that would cost a lot to the operators. Now, these are our new generation LWSI that we have proposed in India. We have also made certain test cases with Indian Railways, and of course they are in service in UK, in Australia, in Taiwan from last 10 years. So here you would see it's a close contour design. Thereby there is no loss of contact between the LWSI and the pantograph, because in case of any open gaps, there would be hard points and there can be certain issues with the panto passage. Narrow design, and this is very useful because what we have seen that the strip of contact surface of pantograph may not be always flat. So in case, so wherever we have a narrow design as possible, then the pantograph does not have to change the height or adjust the height accordingly. So thereby it will provide a better panto passage. And this solution comes with spring droppers, because what we have seen, buckling can have effect, and we have seen most of the failures on LWSI and section insulators are mainly on the dropper side. So in order to avoid that scenario, we have offered now our new LWSI as well as neutral section with spring droppers. As I said, the new generation LWSI is with a closed frame, so no hard points, no gaps. Instead of runners, we provide low wire gliders, and it's against in a closed format. And then the flexible design prevents hard points in the catenary. And finally, the length of our new generation LWSI is around 6 meters, so it has a better weight proposition. So in reference to our installation base for new generation LWSI, as I said, we have installed in Australia, Austria, Germany, Switzerland, Taiwan, and UK. So this would give you an example or the test case how the performance of the new generation LWSI will implement for a smooth transition of the pantograph. So you have seen here that the train has gone, but the panto with the upliftment of the LWSI is at its minimum, thereby giving a better life of the LWSI, as well as it would avoid any downtime. Now, I will talk about the neutral section because that's our signature product, and as I said, we have more than 4,000 installation in India itself. So this is an example of how the neutral section looks like in an installation base. And this is our new generation neutral section with a single rod. This is again built with the idea to have a low life cycle cost as well as to provide a better performance. And this is very interesting for heavy haul as well as for high speed operation. And the speed potential for such neutral section is up to 250 kmph. These are easy to install, and they are again with the same philosophy of our conventional neutral section with the rotation of the insulator rods. They are very low weight, low wear due to single rod pattern. So this is an example of our new generation NSR neutral section installation. Now, apart from LWSI and neutral section, we do have other components for OHE fittings. I'll just quickly go through them. So these are our fittings item that we offer for different application. We have the ending clamps and the catenary splice. Some installation example of these products. Then we do offer different kinds of catenary suspensions, the droppers. One interesting product what we have been offering in India to Indian Railways, to different metro operators is the current carrying adjustable droppers. Because what we have seen that in India during our discussion also with DFCCIL, there are issues with droppers. We have been seeing that there are lots of failures with droppers, and in droppers, there are three different players. You will have the clamp suppliers, then you have the conductor supplier, and you need to install the dropper on site. In order to bring some new innovation in this regard, we have introduced adjustable current carrying droppers where we take the complete ownership of this dropper. If you look into the catenary, the catenary side, it's a factory pre-crimped dropper. I'll just quickly show you the installation because I think it's very interesting. So here you will see that no special tool is required to install this dropper, no crimping machine on site. So, and whatever the access wire we have, we can just place it on the given slots. So this dropper is installed. I'll just take. We do have other splice fittings. We have earth claim solutions. We do have solutions for safety and earthing. And finally, as Earther-Flurry India, we do provide the local support, because for us it's very important to be close to the customer. So these are some of our before and after sales customer support, and this is specific to India. So wherever you will also see that we are impacting given the training at DFCCIL Tundla Depot. So thank you so much.
Thank you, Mr. Amitabh. The presentation reminded us that system reliability is often determined by the performance of smallest but most critical components. We move on to our last presentation. Few railway technologies have generated as much interest in India over the past decade as Kavach. Developed as an indigenous ATP system, Kavach represents a significant step forward, enhancing safety, operational confidence, and future network capacity. While much attention has focused on deployment across Indian Railways, DFCCIL presents a particularly interesting operating environment due to its dedicated freight operations, long train lengths, and high capacity design philosophy. Our final speaker in this session is Mr. Arjun Singh Tomar from DFCCIL. His presentation is titled Implementation of Kavach in DFCCIL. Mr. Tomar, you are welcome.
Thank you, sir. Good afternoon to all, respected MD sir, director sirs, my distinguished guests who has come for this seminar, my all senior officers and friends. I am thankful to all for giving me this opportunity to say my view on the implementations on the Kavach and DFCCIL. So here is my agenda. Kavach is basically, I am feeling proud to say that it is one of the indigenously developed technology in Indian Railways, where we have, along with our industry partners, we have developed with our RDSO support and Indian Railways support, and it is being implemented not over in Indian Railways completely, and we intend to export it to the countries, as is the vision of our respected Minister Sir, of which we have seen, and we have listened to him in a lot of forums on that. So first few slides I will discuss about briefly about the Kavach, then I will straight away come to my implementation plan on the DFCCIL. What is Kavach? Kavach is basically a train collision avoidance system. As we know, it's an automatic train protection system. It does a SPAD protection for the, if we say it's a aid to the drivers for stopping them in doing the passing of the signal at danger. Then speed control, because its working philosophy is the distant time graph. the onboard system continuously watches the distance to be covered with the train speed. If the train speed is not within the control, it applies auto brakes. Then there are some additional features which is specific to the Kavach, though will use a caption here that it is not SIL4 as we say about the SIL4 technology, but yes, it prevents head-on collision, rear collision, side collisions, and it has some additional features of automatic whistling at LC gates. Then it has a feature of giving SOS command and SMS to the stations and to the loco. So these are the additional features if we compare with the world-class ATP systems which we have developed and which are fully functional here. So coming to the journey of the Kavach, it all started around 2012 when the word TICAS has come into the picture, and I must name the companies which have all together with Indian Railways, namely Carnex, Medha and HBL. These three companies along with RDSO and Indian Railways, they have worked all along I can say next 10 years for stabilizing the technology. And in 2018-19, when the SIL4 certification has been given, then the Kavach version 3.2 was told that yes, it has been approved, and then the I think the first tender was given of some 1200 kilometer to South Central Railway. So first largest scale deployment started there. So coming to the timelines, in 21-22 we have deployed around 1500 kilometers. Then in July 2024, gaining the confidence of the Kavach 4.0 version, which approved with increased redundancy, has been come up, and from there onwards it has come in the vision document and in all the railway plans that okay, we'll deploy Kavach all over the Indian Railways as our indigenously developed ATP system. And as we can see that the figures, if I'd like to attention of the bottom figures, around 24,500 kilometers trackside equipment tender has been already awarded. Some 9,000 loco tenders have been awarded, and out of that some 1,862 kilometers of section in Delhi, Mumbai, Delhi, Havra has been commissioned for the trackside system, and around 5,000 locos has already equipped with the Kavach loco onboard equipments. As I have told, if I'd like to recall that the idea of giving independent tenders for the Kavach onboard system to the loco manufacturing unit was that even if the deployment of trackside equipment takes time, the onboard system deployment can help in preventing the side collisions and head-on collisions and all. So with that view, the independent tenders has been given and it has been awarded, and it is showing result also. As we can see that out of 9,000 loco tenders, some 5,000 already been deployed in the sets. 15,000 plus persons have been trained. Out of that, some 47,000 persons has been trained are loco pilots for the Kavach. The training emphasis is going on, and it is training is being given to multidisciplinary, including the rolling stock, including the mechanical, including the operating, all the persons involved in the operations of the track, engineering, everybody is being given the training. So just a brief architecture is the station Kavach consists of the station signal interlocking interface, where the signal, track, point and other aspects data is being captured by the station Kavach. Then it communicates to UHF to the onboard system, and there is a RFID tracks which is placed at every kilometer and at every signal and point zone fitted on the sleepers in between the rails, which are communicating and giving the exact position of the position, location and the direction to the onboard system which is installed on the loco Kavach. Communication is fail-safe UHF technology, we have some 7 pairs of UHF frequency in the range of 416.8 to 466.8 megahertz has been approved by WPC for us. Out of that, 5 we are using and 2 are spares, which I'll discuss in next slides. Then there is a, we have a KMS, key management system server, which has been placed by Railtel. There, every station and every loco is first authenticating itself. Once it is getting authenticated, then only its transmission or its communication starts. So that communication is being done through GSM SIMs, which has been provided. So that key management system is taking care of the real authenticity of the equipment which is using Kavach. Say small about the system architecture. As I have explained, the stationary Kavach unit is there. Then RFIDs are there. Then communication backbone. Then loco Kavach and the network management system for discussing and for monitoring the entire system. Something about the real pictures of the equipments. These are the loco equipments. In that loco TCAS is there. One OCIP is there, operation communication panel, which is in front of the driver. Then the brake interface unit is there. Then RFID reader is there, which is putting in the bottom of the loco for reading the RFID data. Station TCAS is there, radio towers, and station managers, some OCIP is there for looking the important parameters. And bottom is the our rail interaction. I can say that is the RFID tracks. RFID tags which are provided on the sleepers. It is provided at every kilometer, and in the near the signals there is one signal, and one approach RFIDs are provided at 200 meters. Just to increase the reliability of the system, now the at every RFID within a distance of 3 meters, one more standby RFID is being provided, so that if any data is misses or any RFID tag is tampered or something, the communication should not break. So these are the communication. As I have told that if I can read out the item number 2, if last packet from station Kavach is more than 6 seconds old, signal aspect and description go blank on the driver display. So this is the safety features. Within 6 seconds, if the station is not communicating about the signal aspect, it will go blank and it will come in the limited supervision mode. Similarly, communication failure is getting detected. That item number 3, if I can say that failure declared after 30 seconds in absolute block or 10 seconds in automatic block section with no data received. So these are the safety features. In case the data is not there, it will come to limited supervision and it will give alert to the driver. And if the driver is not reacting within a certain time, service will be applied. And all the alerts will go to NMS. Coming back to regulatory provisions, as we all know that we are governed with the Indian Railway General Rules. So once the Kavach has been, it has been decided that Kavach will be proliferated in Indian Railways. So the rule has come up in GR 1.02 through gadget notifications that once Kavach is there, it has to be followed by all the drivers in the Kavach fitted loco. So then coming to our DFCC implementation, it is in 3 parts. In double line section of 931 kilometers, that Kavach tender is already awarded to Mrs. Karnex and KC Consortium. The award has been signed in 4 December 2025, and date of completion is about 18th December 2027, and 930 kilometers of double line section tender was awarded. EDFC single line 400 kilometer tender, it is already, the tender document is already under preparation and legal vetting, and the NIT will be floated shortly. For WDFC, we have sent the proposal to Railway Board. Once it is got approved, then we will go for the tendering phases. Only trackside equipment we are providing because onboard is coming from the pre-fitted from the IR side. So in our progress, that desktop and LIDAR survey is completed, tower deployment plan finalized, station ID has been allocated, frequency planning has been done, Survey of 150 location completed, soil testing, 150 new towers are coming. Out of that, all 150 survey has been completed. Soil testing of 110 locations has been completed. And then equipment inspection and tower supply and erections are in progress. As on date, out of total 50 sets of tower has been supplied and 25 has been installed at in Prayagraj unit mostly. These are some of the figures, as I have told, nothing much in that. Like this is just trying to deploy how the tin diagram and RFID diagram shows. At every signal there are 2 RFID tags are there, which are identifying the signal and which are taking the geographical location and direction of the travel. So these are some of the challenges. One of the main challenge which is still there in a DFC tender which we are facing, that we have 3 types of EI, one Kyosan, one Siemens and one Alstom. With Kyosan and Siemens, the tender has, the RDSO interface is already developed, so there is no issue. But with Alstom, there is no interface developed, and that is a challenge for Kernex also, that to see that, because I have discussed with RDSO and the procedure with RDSO is quite long for developing a interface. So we have either a time way out ki we can do develop the interface and do some independent ISA and get it approved, as we have introduced the Alstom EI in DFC. Other way we have to think of any other solution, but it is a really critical problem, because RDSO approval is taking its set procedures. They have the lab testing model, they have to do the testing, and it is a time consuming process. Allotment of station ID, we have approached RDSO and we got it. The next part is frequency planning. Actually, sir, out of 931 kilometer, around 700 kilometer, we are parallel to the NCR. So all the 5 frequency out of 5 frequencies, NCR has used. So when we approached the RDSO, they said that you approach NCR. We told, sir, how NCR will give us the planning. So they have given us the task. You see where the frequency has been used by NCR, that at that place use, let us say F1 is, where F1 is used, you use F5, like that you interlink the frequency and do your parallel things. So we have done, our team has done in that manner, and we got approved 1 frequency plan. So that's the next challenge was interchange station, because we have some 18 interchanges, sorry, here it is 16 it is mentioned, 18 interchanges with IR, and the interchange is hardly 2 to 4 kilometers. There is no not much bigger interchange. So we find it very difficult to develop a logic that seamlessly the train which is entering from IR side to DFC and from DFC side to IR, it takes care of the smooth interface at the junction station. So what we have done, that we have said, okay, let us call a end of station and start of the station. It will be a better way to implement the project. And that is the only solution, because in 2 kilometers you cannot do the switching from the one set of technology to another set, because altogether station ID, frequency, everything is different. OFC health was one issue, sir, that we have taken care. Then the yard alteration for the EI modification, because every second or third station we are going for the Gati Shakti terminals and we are changing the EI modification. Then LC gates are getting closed, so that EI modification. So we have to keep our eyes and ears open, that when the next some changes is coming into EI, and try to finish our Kavach identification and Kavach work in that slot only, so as to avoid any both cost and the complexity. So from training point of view, we have also nominated around 100 officers. We have got trained from IRSET, from multidisciplinary team from the DFCCIL. All of our team is getting trained, because the DFCC, in DFCC also Kavach is being introduced. So in cost optimization, we have some added advantage over Indian Railways implementation, as we have already OFC cable laid, which is used in Indian Railways. They are laying altogether new OFC cable, so that time is saved. Then GSMR towers we are having, which towers we can use for the fixing of the AT Kavach antennas. Then buildings we are having all together, and we have designed our ATP system in such a way that every tower is coming at the building, so that there is no new building construction is there. And the same ALH building, some 5 kilometers, we have the advantage of having building at every 5 kilometers. So that same buildings are being used. So new buildings are coming, and the existing power supply also we are using. So there is a saving on power supply. So these are the factors which has helped us in faster implementation of the Kavach. Future plans, it's already I have discussed that a single line is approved, double line that kept ongoing, this training is ongoing process, and it's all EWC we are doing in the new corridors. These are some glimpses, sir. As I told that on 4 December 25, we have issued the contract agreement. Then the Bhumi Pujan was there in the Prayagraj unit. Then there's one picture of on February we have done the progress review meeting when the Carnex team was called for. There are some tower instructions. As on date, 25 towers has been erected like that in Prayagraj unit, and balance 25 base foundations are being completed. So in concluding that it's a necessary part that if you want to go for the zero SPAD and collision free freight operation in upcoming EDFC, we are planning that we will go simultaneously, because we have seen that going beyond in retrofitting mode, we are facing problems in Alstom, and maybe in forthcoming Hitachi also the same problem will come, because these are not the RDSO approved EIs, where the Kavach implementation is Kavach and EI interface has already been developed. So in EWDFC, we are planning that right from the start we will do the Kavach work with the EI itself. Then then onboard Kavach we are planning, sir, because we have the track machines and tower wagons where we can do some onboard ATP system also we can install, so that we can do our own testing and our training to our DFCCIL officials. So that once we are ready with the our trackside installations, any ATP fitted, Kavach fitted loco is coming, so it can run smoothly on the DFCCIL network. So that's all from my side, sir. Thank you.
Thank you, Mr. Tomar. The presentation beautifully covered status and challenges in implementation of Kavach in freight corridors. Now we move on to our question and answer session. I will first request Sri Sugam to answer some questions. Slip is with you.
So I've got two questions. The first is how can GPS detect the vertical vibration of axle box? So GPS will not be used to detect the vertical vibration, so it will be used to basically compare different locomotives which have gone through the same location. So the vibration of one locomotive is compared to other locomotives which have gone through the same location, so that we can cluster the defective locomotive away from the safe ones. So that's the answer. Second question has two parts. So first is how does the rail ghost work under stationary rolling stock? So rail ghost is basically an automatic maneuvering device. So it's a robot that works on the rails. So it basically moves below or under the deck through the rails, and it scans the entire rolling stock. And the second question, and the second part of the question, it is about the thermal cameras and acoustic sensors may not work. So it is regarding that. So for the acoustic sensors, we use like heavy signal processing on the data that we receive, and within a specific frequency range, we compare the data so that we can flag the unhealthy locomotive or unhealthy axle. And regarding the thermal camera sensors, so the question is, if there is a less temperature, then we may get erroneous reading. So the thermal cameras, they also help for axle to axle comparison. So we have, let's say, 6 axles. So we compare the data of one axle with respect to the other axle. So that way it helps in identifying the defective one over here. Thank you.
Thank you, Sugam. Now move on to Mr. Ghosh. You are having lot many questions.
Yes. Thank you for the questions. But before getting into the questions, I think it's very important to understand that neutral section is a passive component in the system. And we have to look neutral section from the holistic approach, because as Arthur Fleury, we are not the system designer. So we are offering this component, and most of the technical questions that I have received is on the functionality of the neutral section and how it behaves in different environment. I would also like to take this opportunity to invite each one of you in our booth next hall, because in order to answer these queries, I believe it's very important to show you the unit, how it behaves. We have different presentation. I am available here with my team, and we can take all your queries and can answer you more in a detailed way. But I will take few questions. The first one is, I've been asked about the weight of our neutral section. So that's around 55 kgs. The other interesting question is about the Make in India requirement and how we as Arthur Fleury India, we are able to fulfill it. As I said, our facility in IMT Manesar, we are able to do certain final assemblies in India. And by virtue of this, today Arthur Fleury India Private Limited is an approved RDSO vendor for neutral sections, and we are a class 2 supplier. So our local content offering in our product ranges between 21 to 30%. This also depends because most of our components are sourced from Switzerland, and as you know, the current geopolitical situation, the currency fluctuation, everything has an impact on our final calculation of local content. The other interesting question I've been asked is, what happens when the loco goes with traction beneath the neutral section? I believe the product is not meant to have this accessibility that the loco goes with the traction, but yes, it happens. And of course, we have been imparting trainings in India, because I believe the training is a very crucial role in order to impact, to make better understand about the product. So that's an exercise what we take as Arthur Fleury in India, and we got a very good feedback. And if I'm not wrong, we have done more than 8 workshops with DFCCIL also. Of course, there were certain issues with the performance of our product, but I'm happy to confirm that we have resolved all of such issues, and now it's working absolutely fine as how it's been done with the Indian Railways from last 30 years. Thank you.
Thank you, Mr. Ghosh. Now move on to Mr. Tomar.
Thank you, sir.
Keep in
Sir,
mind.
there is one interesting question has come to me. Thank you for, I could not get the name. Actually, it's a comparison that why is Kavach being planned for DFCC as a standalone apart from IR plant? Like in case of RUBs and ROBs, we have to treat IR and DFC as one unit. Let us plan it in, let us put it in simple way. It can be assumed and have 4 tracks, 2 for the DFC main line and 2 for the IR lines. Kavach can be planned in that way. It's a good way. It's a good system, but there are some different perspectives from my point of view. First is the that IR stations. As I have told, that IR stations are getting different station IDs, and the antennas, the communication is the lobed pointed antennas kind of thing, lobed one in that direction itself. And the second thing is that in case of ROB and RUB, the all 4 tracks are coming parallels, and it can be one unit thing. But as long as train operation is concerned, train operation can never be in the crisscross movement. It has to be change track in the at the junction where the IR and DFC are crossing each other or jointing at the interface arrangement. So both IR and DFC has to protect their own tracks and their own what is called ATP system. It cannot be clubbed together. Even if we do the joint tendering and we do the simultaneously we can do the work, but their frequencies will be different because it all depends on the frequency where the loco is intercepting the information. So it cannot be clubbed together. So that is the first part of things. The second part, one question has come that what is the cost of per loco? The last information I was having, the per loco cost is around 70 lakhs per loco, and its per track kilometer is around 36 lakhs or 37 lakhs it is coming as on date. It works on different speed, yes, it works. We have the, as the signaling principle goes or the SEM goes beyond 160 kilometer, ATP is mandatory. But now because of this SPAD and there is so many automatic signalings and everything is going, so we are going for the ATP indigenously for entire track, because driver is seeing so frequently he is coming across a signal and he should have one kind of protection with him. So in my view it is not about 160 kilometer, even at 100 kilometer also the ATP is being provided. OHE interference does not affect, no, it is not, there is no interference as long as I am seeing that any interference is there with the OHE. So that's it. One message is there for me as a congratulations. Thank you, sir, for that.
Thank you, Mr. Tawar. I may like to add that it cannot be clubbed with Indian railway stations, that Kavach, because the inter-station distances in the Indian Railway is around 4 to 5 kilometer, whereas DFC is having 30 to 40 kilometer inter-signal distances. And the Kavach is the distributed system installed at every station. Data is coming from every station, so we cannot club both the system technically. Thank you, Mr. Tomar. Thank you all our presenters. Ladies and gentlemen, today's discussion highlighted the common reality. Heavy haul railways are entering a new phase of evolution. Success will no longer be determined solely by a stronger infrastructure, but by smarter infrastructure. The railways that thrive in coming decades will be those capable of transforming data into decisions, maintenance into predictions, and technology into reliability. I sincerely thank all our distinguished speakers, delegates, and organizers for making this session a success. Thank you very much.
Thank you very much. A round of applause for all the speakers of this session. The session underscores a fundamental reality as freight volumes continue to grow. The success of high-capacity corridors will increasingly depend on intelligent systems and resilient infrastructure. Ladies and gentlemen, before we finally move forward, may I please take the opportunity of requesting Director Project Planning, DFCCIL, Shri Pavan Kumar Raiji, to kindly please present tokens of respect and appreciation for each of our speaker. We request you, sir, to please present tokens of appreciation mementos to our speakers. We begin by thanking Mr. Manish Kumar Chauhan, a DFC memento, and along with it we have the Statue of Unity, serving as a symbol of national unity and pride. We also have the technical compendium of the seminar. Thank you, Mr. Manish, for sharing your expertise. We move forward and thank Mr. Kaushik Nag for his sharings. Thank you very much. And once again, a round of applause for each of our speakers. Thank you, Mr. Kaushik. We thank Mr. Ganesh Kumar Dwivedi for sharing his presentation with us. A special DFC memento to start with, followed by the Statue of Unity. We would now be presenting the mementos to Mr. Shubham. A round of applause, ladies and gentlemen, as we take the opportunity to pause and thank each of our presenters for their sharings. We thank Mr. Amitava Ghosh for sharing his expertise with us. सभी के लिए जोरदार तालियां हमारे सभी स्पीकर्स के लिए. The technical compendium of the seminar. We take the opportunity to thank Mr. Arjun Singh Tomar for sharing his presentation, his thoughts with us today. Thank you, Mr. Arjun Singh Tomar, for sharing your expertise with all of us. And we present a memento to the moderator who conducted the session really well, Shri Kailash Kherotia. Thank you very much for moderating the session. Ladies and gentlemen, please join hands as we thank the moderator and the entire panel for bringing about such meaningful discussions and enlightening us with their discussions. Thank you very much. With this, ladies and gentlemen, we quickly move forward and we now move from individual technical presentations to a broader strategic discussion. Due to dearth of time, I'll be hurrying up with introduction of this session. This panel brings together an exceptional group of international experts whose collective experience spans some of the world's most advanced railway systems and technology organizations. This discussion will be moderated by Ms. Carrie Gonzalez, Chairperson of the Internationl Heavy Haul Association and Chief Executive Officer of MXV Rail, one of the world's leading railway research, testing and technology organization. Joining her on the panel are Mr. Marcel Taubert from Vossloh Rail Services, Germany, Mr. Brandon Riddering from Lorem, USA, Mr. Jackie Westhuizen from Ensco Rail, USA, and Miss Emily Kent from One Big Circle, United Kingdom. Together, this panel offers a unique opportunity to hear perspectives drawn from multiple continents, operating environments, and technology domains. May I please request Ms. Carrie Gonzalez to please begin the discussions from here.
Perfect, thank you. And I know that this panel is between everybody and lunch, and so I'm only taking yes or no answers. Perfect. Okay. Well, thank you so much again for the opportunity. In my keynote yesterday, I made the point that reliability is not the outcome of a single asset, a single decision, or even a single organization. It's really a system outcome built over time through integration of infrastructure, technology, data, and people. And so what makes this panel particularly special is that it really reflects all of that in practice. So around this table, we have 4 distinct perspectives on the same challenge, really the rail itself and its broader track infrastructure, how do we inspect it, how do we monitor it, how do we maintain it. But individually, each one of them has some very critical information, but together they're helping to define what performance looks like. So today we're going to move beyond a single viewpoint and really move into those larger perspectives into this conversation, so that we're able to really see how this work is done at scale. So I'm going to start with a question for all of you. Marcel, I think I'll start with you, and then we'll go to Brandon, Jackie, and then Emily, you'll round this one out for me. But in your experience across the world's mature heavy haul systems that you guys have interacted with, what is the single biggest change in how we deliver reliability today compared to 10 years ago? And is it a change in technology or a change in mindset?
Yeah, thank you, Carrie. I would like to refer my answer especially to the infrastructure, because this is where I'm most experienced in. I would say, looking back last 10, 20 years, biggest change is maybe in the collaboration model between industry and railways. I think we have seen, and we've seen that here in this presentations, that when we look back, let's say 20, 15 years, there were a lot of railroads were quite a closed shops, done everything from research to operational models, design of tracks, design of components, and suppliers often have been a simple supplier, and that has changed. More and more suppliers become solution providers, and that, I think, is something which is extremely important to get momentum into the development of our industry. And we've seen in the last 10 years, as well as the infrastructure. In rolling stock, I think we have a different picture, but in the infrastructure we've seen a certain momentum. And maybe a last comment, if you allow me to look into the future, I can expect even coming as an industry from not only a solution but a function provider in the future. And so that's, for me, the biggest change I've seen.
Thank you. Brandon, I'm going to kick that one over to you.
All right, thank you. To the part of the question, is it what's driving? Is it technology or mindset? I think that's a little bit like the chicken and the egg. It's hard to distinguish between the two, but certainly technology has changed the precision in which we're seeing maintenance provided or deployed. Over the last 10 years, I would say mindset was questioning of technology, and in the last 10 years or so, technology has just been embraced and been utilized, and it improves every day, and so therefore it makes all of us better at our jobs and gaining momentum towards our goals. So I think that at this point, we're not going to stop. Technology is going to continue to drive improvement, and I think if you look across all our our heavy haul partners around the globe, if you look at all of their statistics, every one of them has improved, from safety, clearly reliability, momentum on their networks. There's proof around the world that technology is creating positive changes, and that I believe that'll continue. So thank you.
Perfect. Jackie, you're up.
Thanks, Gary. Maybe I will kick off with yes. Making it easier. So for me, and based on my background internationally, I would say both. That's really, for me the answer. If we look at the past 10, 20 years, I would say, definitely 20 years ago, maybe a little bit different 10 years ago, the railroads in general were in a corrective maintenance mode. So fix it when it breaks in general, or if we had some luxury, we would have done routine maintenance. I think where we are today, we are starting to ask different questions. We're starting to ask questions like, what can we do to prevent failures? and that's why I'm saying both. So on the one side, I'm saying technology enabled us to make a move and make a shift. It's really technology bringing some visibility through data. But then from a mindset perspective, you know, I think we transformed as a industry in a mindset where we said, well, we don't want to be corrective. We really want to be moving towards condition risk-based assessments. So in general, my quick answer is both.
Perfect. I think that's a fair answer. And Emily, I'm going to go over to you, and I know you're going to bring a little bit different of perspective. So I'm going to give you a multiple choice option here. You can talk about historical thing, but I think it's really cool that you are now in the industry coming in new. So maybe you could talk a little bit about what has surprised you coming into the industry as well, but your choice.
Okay. So yeah, I was going to say we don't have the historic context to draw on. So I was going to say from a mindset perspective, in the time that we've been working in rail, the last 6 years or so, the appetite and enthusiasm for the change in technologies is actually what brought us into the rail industry. Sometimes I like to say, I'm glad I didn't know what we didn't know before we started, based on some of the challenges that we've come across, but that mindset has helped us overcome that. And when I think about it from a reliability perspective, what that means to us is that once building that IM system that relies on data, that's where you have to have consistency and the ability to deliver that, because there's no point in building a monitoring system that's going to rely on data that then is not consistent. You can't rely on it. That's when you lose that confidence and that mindset as well. So you have to be very cautious about not going backwards in that confidence of what technology can bring you as well.
Did I like all of the answers were pretty spectacular, but a few things that just I quickly wrote down was something that I appreciate about the industry is in the form of collaboration. But I think the one underlying theme that everybody was talking about is this acceptance for change and adaptation in our industry, which I will note is a little bit challenging when you talk to technical people. Don't tell them that we're excited about change. But I do think it's great to see that technology is driving this natural evolution of the industry, and people do have an appetite for change and proving to be able to get into that preventative state rather than a reactive state. So we're going to move on to a couple of paired questions. And in his opening address, Mr. Kumar described DFCCIL becoming like the first entity in India where they're looking at more comprehensive O&M programs for rail grinding and tamping, deliberately shifting from these singular short-term contracts to longer relationship-built contracts. And so, Brandon, I'm going to go to you first, and just highlight that DFCCIL has contracted with LRAM to commit to a 12-year maintenance contract because reliability really is sustained over decades, not in these short bursts of time. So when you look at that and how that contract is measured over a decade rather than just a single delivery date, how do you feel like that changes your organization and how you work and how you're investing in the railway and being more present in India as a supplier?
Sure, thank you. It's a really great question. I guess for just a little bit of background, having long-term relationships is in the DNA of LRAM specifically. In fact, if you look at the naming convention of LRAM, the L and O stands for long, and the RNA stands for range, so it stands for long range, and then the M stands for the initial of the ownership of our company. So long range is in our naming convention and is what we've always strived for. And the benefits that it's always provided is it allows us to get to know our customers and to understand what their problems are and remove ourselves from just being a transactional supplier. It's pretty common to buy something. Do you think it fits the need? It probably does, but then that's really the end of the interaction if you don't have that long-term relationship. And so what LRAM strives to do, and I think all of us who have long-term contracts with our customers and vice versa, you get the ability to understand how you're deploying your solutions, right? And those solutions can be data, they can be track equipment, whatever the case is. But if you're both intimately involved with what the solution is and what the problem is that you're trying to correct, it opens up so much more trust and better dialogue and communication along the way that you can actually have meaningful outcomes. And so that's what we strive for. It's much, much tougher to get to if you're in a transactional relationship. And so, again, it's part of our DNA. It's a wonderful business model because we're all in this together and we all have the same objectives. And when you get to that point, it's a game changer from a productivity and ownership perspective.
Awesome. And this kind of similarly go to you, Marcel, that you've been providing similar services in Europe over long-term contracts in milling, grinding, turnouts, welding. And so can you talk to us a little bit about your experience with these longer-term maintenance contracts and how DFCCIL can really work with its partners to get the best out of a model like that?
Okay. Well, of course, as you can imagine, because Brandon was Loram and we with the rail services are somehow in the same business, so some of my answer will just repeat what Brandon already said. What we, of course, experience is making a long-term relation successful is based on really understanding if we have the same long-term targets. Do we have agreed and aligned on the same targets? Do we really talk about the same? So sometimes this transparency is not as obvious as it should be because you have a lot of expectations with procurement contracts describing very specifically the, let's say, the service itself, but the underlying targets are sometimes not that obvious. Give you an example where with one of our big European contractors, it took us a time to understand that there is a, let's say, a separate currency, what they call lost time units. And this was not described in any contract, but for the customer, extremely important to achieve less lost time units, which is not only to fix rail problems, but as well in the way how you do it. So how can you save track time? So again, what I want to say is most important is that in a long-term relationship, you must be sure that you talk about the same targets and you are aligned on that, and then you can work in a very professional way, achieving a better result.
Great. Thank you both for those answers, because I think sometimes people, when you're looking at longer term contracts, there is this underlying fear of performance issues and how do you manage those. But I think with Brandon, your point on trying to build that trust and relationship and have good conversations when even challenges exist, and then alongside really good metrics on measuring performance and having conversations around that is really, really important. So thank you both for your answers. Next, we're going to move on to our team members from Big Circle and ENSCO. And Emily, I'm going to start with you on this one because Mr. Kumar made a really striking point yesterday to me that is advantageous in the form of DFC's ability to be young, right? And they don't have all these underlying legacy systems that they're trying to deal with. They really are starting with a fresh slate, and your organization is similar in the industry. So I'm wondering, you know, with that lens in mind, if you look at infrastructure monitoring with fresh eyes, where do you see it heading for the next 5 years, and where are you really targeting spaces to be able to improve the industry in that way?
Thank you, Kerry. Yeah, absolutely. We think the really exciting opportunity is to create something network-focused and outcome-driven. It's a real opportunity now to define the technical ecosystem that can then scale and evolve with you. And within that will be the suppliers that you will build your long-term relationships with, as well as indicated by the others on the panel here as well. So at this stage, there's opportunity to set standards now for data, for delivery, for interoperability, and address those expectations with your supply chain so that you are building the relationship with the supply chain that will evolve. So we're not looking at things like, you know, sort of the previous history of sort of maybe black box technology that doesn't actually deliver insights, and the accessibility, which is really key to that progression. The volume of data from everything we've learnt over yesterday and today is only going to grow, from smarter trains, new sensors, etc. So you really have to understand where that's going to fit longer term, and where the sort of corroboration and assurance between systems come as well. So there's never going to be one system that fixes everything, never one source of data that's going to tell you everything you need to know. that aggregation and that integration is really key. And we see sort of what we've learned as well is having the confidence in what's delivered now, what's giving you the insight you need, needs to be robust and reliable, but you also want to create a platform where you're testing new AIs and new sensors, but in a process that builds into your ecosystem as well. So you're not having lots of systems sitting siloed next to each other that you have to then try and work out how they talk to each other. So coming from the big picture is what do you want the future to look like? What information do you need from that? And who are the suppliers, the deliverers of the AI, the technology, and the hardware and the sensors that will build into that and meet your standards of how you want that to be delivered? So yeah, really exciting opportunity.
Wonderful. And so, Jackie, I'm going to move over to you because your organization is not necessarily in that clean sheet state. It's been around inspecting rail for decades, but you've also had to reinvent yourself for the changing conditions that exist in our industry, from moving to more autonomous inspections and continuous inspection, like you talked about with yesterday during your talk. So, on the other side of it, how hard do you think it is for an established organization to let go of some of those old tricks that we may have learned and becoming more in line with industry needs today? And how does ENSCO really approach that?
I don't know whether I appreciate the question, but no, thank you, Kerry. It's a very good question. We in the industry, I can remember when I started. Not going to say how many years ago, but long enough ago. The reaction was in general, but we've always done it like this. That was the general comment from my seniors in a sense. But what I've learned over the years, specifically in the heavy haul freight railroad industry, from my days in South Africa, the US, Australia, a little bit of collaboration here in India, is I don't think that new necessarily means there's an advantage. I think there is value. I do really believe that there's a lot of value. But I also think it doesn't mean that there is a certainty of that it's an advantage. On the opposite side, I would also say, being an established business and have experience does not make us immune to any difficulties or challenges. That is definitely a fact that we will have some challenges. But if we really look at it, and you've actually mentioned it in one of your previous summaries, is if we really look at the successful organizations in the world these days, it's all about being able to adapt. And I would say, from me, it's about adapt and lessons learned. There's a lot of value from history and from lessons learned from industry, but being able to adapt will be the key here. So I would not say it's the old competing with the new. I would say it is more about the best outcome is the old supporting the new and learn from historic lessons. That's my answer to that. I hope that helps.
No, I think that's a really valuable point because I think sometimes we're quite dismissive of things the way that they used to be because sometimes they needed to be that way. And so we have to be careful not to dismiss it just because it's historical, but really to evaluate it and adapt it to the needs of today. So I would say one of the key things that I heard in that is really how do we set the path and then let go of the journey and let people be creative in the space to come up with solutions that are going to match the needs of the industry moving forward. All right, we are going to move into more specific, I'm going to say it's a little bit more technical to think about, and Marcel, I'm going to push this one over to you because you've talked about milling and grinding being complementary strategies, and you need to apply each where it's necessary and strongest. So when you think about an operator that's standing up a heavy haul corridor from scratch, how do you suggest they think about building a rail care strategy that gets the most life out of the asset? And how early does that thinking need to start?
Well, first of all, to be honest, unfortunately, it doesn't happen too often that a railroad asking us already sitting in front of a scratch. our reality is that we are often coming to the game on an installed base, so the railway is already in operation, which of course makes it somehow difficult. On the other hand, in an ideal world, you should already think about a rail maintenance strategy in the moment where you're designing your track and the train operation model, because an optimized rail maintenance strategy has of course an operational influence and vice versa. And to plan that from day one is something which can create a lot of value compared to starting in an installed base where you at the end have to squeeze in your maintenance in an operational model. And starting from scratch means you should, as a railway operator, always try to do as preventive as possible, because that's our experience everywhere in the world. The more reactive rail maintenance is conducted, the more painful it is, the more expensive it is. So as more as you can do preventive and avoid reactive maintenance, the better it is for a maintenance regime. So again, starting on scratch, already plan your maintenance, your preventive maintenance into your train operation schedule, and you can avoid as much as possible reactive. This is what be my proposal.
Great, thank you. And I think that that's another advantage, again, when you're starting with a little bit more of a fresh slate, you're not having to go back. And it's really about protecting the investment long-term than it is to reacting to issues that have existed for years. So, Brandon, moving on to you, LRAM really sees the whole track structure from rail ballast, anything sub-ballast, friction at the wheel-rail interface, and increasingly that data is starting to connect all of them. So where do you think the biggest reliability gains actually hide? In the rail everyone's looking at, or in some of the substructure, wheel-rail interface? I know you're going to tell me all of it, so but I'd like to hear your perspective on, is there something that's getting less attention that we need to be focusing on?
There's a lot to unpack in that question.
I'm asking all the easy ones.
From my experience, I think, and it builds off what Marcel was saying, is that having a commitment to a plan, or having a plan first and then a commitment to the plan is generally considered the optimal way to go about your annual plan, or your planning process and execution process. But I think where things are missed is that there's a lot of decisions made on a daily basis and an annual basis that fix something or address something that day or that week or the here and now, and there isn't always a consideration for the long-term portion of that decision. So when we talk about a lot of assets, a direct freight corridor, for example, have a life cycle, right? And we're always, as a group, we're trying to maximize that life cycle. But in order to do that, you have to maintain it one way or the other, depending on what it is. And so in the example of rail, there's generally a cycle based on MGT that says, hey, we should be here for preventative maintenance, and we all agree and know that that's the easiest way to stay on top of things and not let your rail get away from you. Again, maintaining a state of good repair that's fiscally responsible. But when we start deviating from things like that, now there's long-term downstream effects, and now, as in this same example, rail won't last as long as we want it to, which means that, it's not today's problem, but tomorrow's problem, where we're going to spend more money on rail than we probably needed to. And, you're negating the investment you make today by not using the assets to protect your long-term assets. So it's a real balance, and I don't have an answer for it. I mean, there's problems that come up in the network, and you have to intervene, things happen. But I think that understanding the impacts is sometimes what's missed, right? We have to do what we have to do to maintain safety and reliability. But if it's out of the sequence, what is that downstream effect? And I think that that's often overlooked and is an area of focus that everybody could improve upon.
Well, and I think that's really interesting because, at the beginning of your response there, you talked about establishing a plan. And I think just because you establish the plan doesn't mean that you're not leveraging the feedback that you're getting and updating the plan. So it's that constant feedback loop to say, I set off with really great intentions, but there's feedback over here that I need to be able to adjust that. So probably being a living maintenance plan, not just something that you build once and it stays static on a desk somewhere. I think that's an interesting take on that.
Yeah, you're absolutely right.
Thank you. All right, Jackie, I'm moving to you for your technical autonomous inspection question. So we know that autonomous inspection generates an enormous volume of data, but data isn't the same as being able to take that data and turn it into action. So what do you think it really takes for a railway to, number one, trust automated findings enough to send a crew out and get it fixed, but also how it's often stalling between detecting a defect and actually acting upon it?
Yeah, I think you're correct to say that data is not really the same as taking the action. I think when you ask this, and I'm trying to run you through some files, my own files, it takes me probably back to the early 2000s. At that time, I was a young. No, I'm still young. At that time, I was another young man working as an engineer in Transnet, in South Africa, Transnet for the rail, that time Spoornet. And in one of my first tasks was really about data and validation of data. And in that year, it was our first time that we implemented ultrasonic rail fall inspection. And I can remember very well that, for the first 6 months, there was a real challenge for our people to actually trust the data and utilize it in terms of decision making. And what I've learned through that process, it is really a big part of it was validation. It was doing testing, going out, cut the rail where we think there is defects. At that time, we were thinking it, we were not sure. And through that process, our technicians really started to see the actual measurement is validated by what we find in the field. So that validation had a huge impact on our adoption of that technology and starting to trust it and to say, well, we need to do something about it. I think also part of it is as they did validations and we see these enormous defects, whether it was welds, whether it was transverse defects, whether it was split heads. It was really interesting to see how the people starting to realize, but wait a minute, there's something that can look into the rail to tell me there's something going on. And I think part of that was also the understanding that if I don't do something about it, it can actually have a huge risk impact on the industry. So if I can summarize it, I think to really trust data really depends on 3 elements. One is the accuracy, 2 is seeing it over and over again, repeatability, and then the context, the what if we don't do something about it, what can the result be? So that's how I would say I think it's predominantly driven through validation. That's how we create trust.
Perfect. Thank you for that. And I think we have time for one last response. And Emily, I'm going to move over to you for the last of it. Obviously, cameras on trains, not a new novel technology in our industry, but it really took a company like yours that's newer to the industry with newer experience to actually turn it into something that a network is actually putting to use today. So talk to me about your perspective on why you think that the technology hadn't been advanced to where you have it today and where you think the next breakthroughs are really going to come from.
Thanks, Kerry. Yeah, absolutely. We've always said cameras on trains is not the new concept. It's what you do with it that counts. And I think, as I mentioned in my presentation yesterday, that accessibility was really groundbreaking in what we delivered in the UK at the time. And then we built the authority that grows with combining data sources as well, as we've talked about as well. So, and that came with building trust with us as a supplier, learning that our skills were deeper in the technical side as well. We came from a different industry where we'd handled video at scale for sports broadcasting. I was told to mention cricket at some point, so we used to do a lot of broadcasting cricket from across various county championships in the UK. A change of circumstances meant we moved our skills and capabilities into the rail industry, and it was they really enjoyed our new approach to data. I specifically remember some engineers on the NMT, the flying banana yellow train, saying, oh, we never knew we could get the data if we wanted to. We didn't know that technology existed, and that's because that insight hadn't been provided by the provider of the actual hardware. So what's really important is that technologists and suppliers of both hardware and software understand each other's challenges, the things that they've overcome to make things work, but also how they can work together as well. So that's really key, and that's grown hugely over the last few years in our work with the AVA system, because hardware itself is not the breakthrough. It has to live within the ecosystem, and the ecosystem has to deliver what the end users, people that are needing to monitor and maintain the system, really require to deliver in this changing environment, the changing resources, etc. as well. So there will always be fast-moving technologies. There will be things being shown that are shiny and new and exciting. There's things that are evolving from what have been established to date. But it's how do they live in that ecosystem, and how do they deliver within that system? Yeah.
Yeah, and I think that that's special because there is always going to be some new bright and shiny toy out there, but until you get the vendor into the environment and understanding that environment, you're not necessarily going to be able to get the full benefit of that technology.
Yeah. How does it cope with the challenges of that environment as well, which are really particular to heavy haul railway as well.
Very good. Well, we appreciate you taking the time to learn about our industry with your application. I think that wraps us up for the panel, so thank you to all of you. But if there is one common thread that we saw across everything that we heard, it's reliability is not something you purchase, right? It's not a one-time transactional state. It's something that you really build and sustain over time. So, and we do think that, DFC has a distinct advantage in its ability to be really intentional about the choices that they're making right now and the alignment straight from the start. So, suggesting you're not simply adopting an existing model, but you're really reshaping a system that reflects where this organization needs to go and the industry is going as a whole. So it's not an easy path, but definitely a powerful one. Thank you again to all of the panelists. You guys were fantastic with short notice on the questions that came out, and again to the DFCCIL leadership for being able to put this conversation together. Thank you.
Ms. Carey. And our sincere thanks to all the panelists for such a rich and candid exchange. To hear the rail care, maintenance strategy, inspection and digital innovation perspectives in one conversation drawn from heavy haul systems across the world and increasingly from India itself is exactly the kind of cross-system learning this seminar exists to create. These global perspectives set the context perfectly for the Indian experience we turn to this afternoon. So ladies and gentlemen, once again to remind everyone that we will be having a lucky draw today evening, and winners must be present in the hall to claim the exciting prizes from DFCCIL. And also another piece of important information, we are also organizing a guided tour of the heritage landscape on Kartavya Path. The tour will start at 8 a.m. tomorrow morning from Rail Bhavan, covering Vijay Chowk, President House, War Memorial and India Gate. Interested members may kindly register their interest on the registration counter outside. So well, with this we conclude this session. Thank you everyone. Let us break for lunch and reconvene at 2:15 for the subsequent technical sessions. Thank you very much. So we'll see you at 2:15. Thank you. Soon we will begin with technical session number 5 on the institutional learning, logistics impact and Indian heavy haul expertise. This session will be moderated by Mr. Manjul Mathur. We're waiting for our other delegates to join in. Just about a few minutes and we will begin with the proceedings of this session. Post this, we will announce for the lucky draws. We have 10 in number, and then the closing remarks by MD DFCCIL, Shri Praveen Kumarji. We are about to begin with the proceedings of this session. May I please request everyone to take their seats. Please be seated, ladies and gentlemen. We are about to begin. Ladies and gentlemen, welcome back after the sumptuous lunch break that all of us enjoyed. And now after the refreshing break, we are back to begin with the technical session 5 on the topic of institutional learning, logistics, impact, and Indian heavy haul experience. As we begin the session, I take the opportunity of introducing the moderator who will then steer the discussions of this session. Shri Manjul Mathur is an IRAC officer of the 1988 batch and a civil engineering graduate with specialized training in bridge and earthquake engineering from IIT Mumbai. He retired as General Manager Rail Coach Factory Kapurthala after a distinguished career spanning key leadership roles in Indian Railways and DFCCIL. He has served as Chief Administrative Officer Construction, North Central Railway, Chief Bridge Engineer, Western Railway, and Group General Manager, Eastern Dedicated Freight Corridor, where he worked closely with the World Bank for 7 years. His notable contributions include leading the completion of the 200-kilometer Khurja-Bhadan section of the Eastern DFC, overseeing the construction of Asia's second-largest operation control center at Prayagraj, commissioning 275 kilometers of railway infrastructure, and carrying out safety audits and rehabilitation of 105 overhead structures on Mumbai's suburban network. Please join me in extending a warm welcome to Shri Manjul Mathur, our moderator for the session, who will begin the deliberations from here. Zordar taliyon ke saath, please swagat kare. Sir, may I please request you to begin the discussion.
Yeah, thank you, Juhi, for that generous introduction. And good afternoon, ladies and gentlemen, and the distinguished delegates. I welcome you back to this final session of the technical seminar. I trust every one of you had a good lunch, and I know it's very difficult to keep attentive after a sumptuous lunch like we had already. But looking at the titles of the paper, I can say that the authors will make this session enjoyable and engaging. The theme, as Juhi has brought out, is institutional learning, logistic impact, and Indian heavy haul experiences. So this is the final technical session, and in this session we'll reflect on the important evolutions in the DFCCIL's journey of implementation of the contracts for the construction of dedicated freight corridor and its operation. Over the past 2 days, we have heard the valuable lessons from the matured heavy haul systems around the world. Our India is no longer merely a participant in these discussions. With the successful commissioning and the operation of the eastern and western freight corridors, and with the sanction of the proposed new east-west dedicated freight corridor, India is emerging as one of the important entity in the landscape of the heavy haul operations. The purpose of this session is therefore to examine how operational experience, research technology, and institutional learnings are shaping the Indian heavy haul and contributing towards the broader international dialogue in the operations of the heavy haul. The paper that will follow will demonstrate as to how India is beginning to develop its own approach to the asset management, maintenance, optimization, and digitization of the railway technologies. As a reminder to all these speakers, I would like to remind that you have an allotted time of 20 minutes. A single bell will ring at 17 minutes. That will indicate that you have 3 minutes left. The 2 bells will indicate the conclusion of your allotted time, and we will resolve the questions at the end of all the presentations. So, the first paper will be presented by Mr. Anmol Kaul. He is from the Plaza India. And in his paper, he will be talking about the modern railway system and how it is being inspected and monitored for the maintenance. So the challenge is no longer acquiring the information. We have been hearing about it. But the challenge is now to transforming this acquired information into the actionable maintenance decisions. A railway that successfully converts the data into the maintenance intelligence will be increasingly able to optimize the maintenance interventions, improve reliabilities, and extend the life of the assets. So our first speaker, Mr. Anmol Kaul from the Plaza India, will discuss as to how integrated monitoring platforms can support the data-driven maintenance interventions. And his presentation is titled Railway Track Monitoring and Fleet Intelligence Using Plaza's Datamatic. Over to you, Mr. Kaul.
Good afternoon, everybody, and a very welcome to everyone who is now keen on learning how the actionable intelligence that we have been talking about has been realized across the globe generally and particularly in India. So I will like to borrow from the wisdom that has been what we have been discussing in the past 2 days. I think a digitalized way forward is a given truth now, but what I want to focus on would be that once we have acknowledged that, what is the next steps? When we talk about digitalization, or for that matter, any intelligence, unless and until it is actionable and unless and until it is actioned upon, it has pretty much no significance. So my focus today in this presentation would be that how do we efficiently dovetail this data that has been collected across different listening devices, sensors, into what finally matters, where the metal meets its counterpart, where we see that finally these actions are taken based on these intelligent inputs. So we know that nowadays the modern infrastructure is getting increasingly digitalized, but unless and until it has a counterpart actioning agency, then that digitalization has of no consequences. So connecting the thread across the infrastructure, the final leg of this digital thread is that when the track is getting maintained. So here I present to you the latest forefronts in the maintenance of the tracks, where we have tamping machines which are digitalized to the extent that the inputs coming from various sources can be actioned and it becomes an end-to-end loop. As my predecessor speakers, eminent speakers were saying, a system is as intelligent as the last leg of implementation. This is the final litmus test of how this actionable intelligence finally meets the track maintenance. So we started with data synchronization, where we want to have some kind of measurement coming. We can have it coming as an absolute or as a relative track geometry. We can then think about how the analysis of these inputs can be done. And finally, unless and until it boils down to what is the work execution and what was as planned and as maintained, then only we will be able to say that we have completed the 360-degree digitalization. So in this concept, we start with acquisition of the data. What we see on the screen is past 20 years of product development into track monitoring systems, which includes the track geometry measurement systems, turnout and crossing measurement systems, clearance and rail corrugation measurement systems, and also the OHE measurement systems, intelligent component video inspection systems. All of these systems, we have been looking in glimpses here and there in the presentations, but what we also want to emphasize here is that all of them together have to provide actionable intelligence. One of the speakers earlier mentioned that today the modern infrastructure is governed by how quickly can you do these kind of inspections. So I'm glad to say that most of the European and American and even Japanese networks are being monitored by these very systems that you see on the screen. We have been fortunate enough to monitor some of the very high speed tracks of the world, including the Japanese tracks that was mentioned earlier. But I would not divulge into each one of the products because then it will take a lot of time. But I would only briefly touch upon some which we have theoretically discussed. These products that you see on the screen, they are fully compliant to the standards that we follow in India. They have been doing these data acquisitions and track monitoring in India as well as I was saying, across the globe. The track geometry and rail profile measurement systems, a very high precision measurement system of very high quality, which enables you to acquire the characteristics of a track geometry. Turnout and crossing measurement system. Turnout measurements in itself is a very complex topic, but to acquire the turnout measurement within a span, very short duration of 4 minutes, and to be able to analyze it under load conditions is something that that is very important as far as the track turnout security and turnout safety is concerned. So that's what we achieve by this turnout and crossing measurement system, which is basically automatically inspecting the entire geometry of the turnout. The possibility here is at very high speeds we can do these turnout and track measurements, and while we are doing turnout measurements we are going to switch seamlessly between the track and the turnout measurements. The another system that we talk about is the track component video inspection system, which monitors the health of the track by recognizing the defects on the track using an AI and ML learning algorithm. Again, my previous speakers talked about the technological aspects of it, but I would say that we have been doing this from last 20 years, and we have implemented and trained our algorithms to address most of the possibilities that are there on the track. This includes different configurations based on different kinds of railways that we have as our customers, and as my earlier speakers were saying, it's not about having the cutting edge technology which is available across the globe. It's also about how you implement it and how you localize it with respect to the specific needs that we have in India. But as I was saying in the start of my presentation, unless and until all of this is collated and turned into an actionable intelligence, and that actionable intelligence is passed on seamlessly to the track maintenance agency, all of this information may not be optimally then used. So here what we see is an end-to-end integration process, and as I was telling you, the last leg of this implementation is the maintenance that happens onto the track. We saw that there are solutions available, products available, which do accurate measurements of the track parameters, but also there are possibilities that there are no measurements available. In that case, still the maintenance of the track has to be done. So our track maintenance machines are equipped with that possibility where there is no measurement available, but there is a possibility of doing pre-measurement. Then the analysis happens on board, and based on that analysis, work execution happens, and once the work is executed, we close the loop. And what I mean by closing the loop is we do a post-measurement, and this post-measurement serves as a baseline for us to analyze how efficiently the maintenance was done. Unless and until this 360-degree loop is closed, the actionable intelligence and predictability of what we want to achieve in today's modern AI systems or any other systems which are analyzing these kind of data, unless these kind of feedback mechanisms are not built, then they may not be optimal in nature. So, moving forward, as I was saying, connecting the dots is what we do. So we have in our machines smart systems which would do the pre-measurement run. They would basically analyze before any maintenance is done. Then there is maintenance happening, and now we shift our perspective from one particular track to one particular zone to one particular region where you have a fleet of such machines. So once I talk about predictability, not only should I talk about the predictability of the infrastructure, but I should also correlate it with the predictability of the maintenance equipments that are operating maintenance. So in order to ensure the entire health of such a system, not only will I profess what is the health of the track, I would also like to profess what is the health of the equipment that is going to maintain that track. And towards that holistic approach, we have fleet management of the machines which are with us, and then we also have infrastructural data that we were talking about, which is coming to us. All of that getting connected by this platform which connects these dots. We have track geometry coming, we have multi-camera recordings of the track, we have absolute track geometry, we have mapping of the infrastructure as a digital twin, and of course we want to move it to inventory as a service. Now while the maintenance is happening, we don't want to tax our customers by going and checking these kind of maintenances, but the system should be smart enough to tell me what was maintained, with what performance was this achieved, and from a fleet perspective, was I efficient in doing this maintenance. So that's where we have intelligence coming in real time about how the track is getting maintained by the tamping machines. So it comes into 3 layers, wherein you have already the threshold set for the machines to operate, which by the way is a smart system wherein the machines tells you that it has exceeded these kind of thresholds and it requires maintenance, basically a step towards predictive maintenance. Now there are different possibilities of analytics. I will not go into the depths of it, but we do offer analytics as a service to our customers, wherein they can pick and choose what kind of problems they would like to solve once all of this data is the dots are connected across these systems. But as I was telling you, the machine, the tamping machines which do the final maintenance on the tracks, they are increasingly getting smarter and smarter. I would briefly touch upon some systems like Smart ALC, DRP, and the datamatic systems. Before we start the tamping, the data is fed into what we call as the Smart ALC, which has the capability of in both the cases where you have a track geometry as well as where you have basically a pre-measurement run. In both the cases, the guidance computer on board will tell the machine how much track parameters have to be maintained and where, and accordingly these parameters are maintained. Once you have done the maintenance, you have the system called DRP system, which does the post-measurement runs and captures how the track was when the maintenance was finished. And then with this information, how much force should I execute, how much vibration should be done based on this knowledge that I have, is where finally I would be able to optimize the process of maintenance. And that's where you have the assistance systems on board, which helps to optimize these parameters, making the maintenance really efficient. You have this is where the intelligence comes to the help of the operator. The machines are capable of sensing where the sleepers are, where the fastenings are, where the other elements are, if there are any other intrusions present, and based on that it works out a best possible tamping plan, and that's our step towards automating this process. Now, but as I was telling you, all of this information on one single page, unless and until I am able to summarize it on one single page, that one single page will not become the source of ultimate truth. So that's why our humble attempt to make all of this come together, wherein you have a Plaza tamping assistant, which basically helps you to identify the positioning of the tamping times, helps you with the tamping unit configuration, helps you with the lifting configuration, helps you with the third rail lifting and identifying obstacles as we were talking. This is basically the data in action. Then we have Plaza tamping control, which helps you to regulate the tamping pressure, tamping depth, squeezing time, and the ballast conditions. And finally, you have a DRP system, which basically helps you to clock the track geometry, the fixed points, the tolerance ranges, and records it for your future reference. We are now shift gears towards moving, scanning the infra with also capturing the ballast profile, the environmental measurements, and the ballast quality, which also gets recorded against the same data sets. So, if I have to now summarize what we want to do and what we have been doing across the globe is combining all of this, the intelligence coming from various sources, and converting them into a protocol that is smart, which is generated out of the inputs coming from all these kind of very smart systems, feeding in the data towards a single page of truth. And that's where I think the future of this actionable, intelligent, predictive maintenance lies. I am proud to also emphasize upon the point that we, being in India for the last 65 to 70 years, have been systematically doing the Make in India, and also for in this domain of digitalization, we have Plaza India contributing towards the solutions that I was presenting. So with this, I would like to close my presentation. Thank you.
Thank you, Mr. Anmol. I think your presentation has focused on the use of actionable intelligence. In the process of our inspections, we collect a lot of data, but the key is to analyze this data and utilize them in making the optimized maintenance interventions. And if through the Plaza's machines you are able to do this, then there cannot be anything better than this for the industry. Yeah. So our next paper is on artificial intelligence, and this will be presented by Professor Sharad Agarwal. Professor Sharad Agarwal is a professor in our premier training institute, Indian Railway Institute of the Civil Engineering, Pune. And he will be talking today about the use of the artificial intelligence in the asset management. As we all know, artificial intelligence is a buzzword of the modern times, and increasingly the railways have also started using the artificial intelligence in practically all the applications, ranging from the defect detection to the maintenance planning to asset management and the operational decision support. From the national perspective, I can say that only few organizations other than Indian Railways are better placed to examine the transition. So our next speaker, Mr. Sharad Agarwal, will be speaking about this use of the artificial intelligence, and the title of his presentation is Transforming Rail Transport System Through the AI-Driven Predictive Diagnostics, an Indian National Perspective. So over to you, Mr. Agarwal.
Thank you, sir. Sabhi ko namaskar. As we know that the buzzword is today AI. Indian Railway is also trying to embrace it. International rail network are the backbone of the modern transport infrastructure, vital for economic prosperity and connectivity. However, the industry faces mounting pressure from the increased global trade and rising passenger demands, alongside challenges related to operational inefficiency and aging assets. In this context, we are fortunate that the DFCCIL, it is comparatively very new. It is not having the pressure, so-called, from that passengers, yet it is connected for inward and outward traffic from the Indian Railways. So we cannot say it is fully autonomous also. In this regard, if we move forward, we have to keep pace with the vision of the Government of India, that is Viksit Bharat 2047 vision. The macroeconomic imperatives, the goal is accelerated national economic trajectory to 8% annual growth rate to realize the Viksit Bharat vision. As of now, if we are progressing at the business as usual and we want to achieve the target national GDP of $8.3 trillion by 2035, then we need to vastly outpace the current projections. Here we can see the current projection is, if we proceed business as usual, it will be about $6.6 trillion. However, we have to touch it 8.3 trillion. So there is a vast gap of $1.7 trillion. That's what we need it. And where is the catalyst? Yes, AI integration as the decisive lever for the pervasive productivity and sector-wide leapfrog innovations. The economic mandate, we have to bridge this gap. The correct trajectory is 5.7% growth, and the difference we have worked out 1.7 trillion, and then we have to reach to 8% of the growth. So the global AI opportunity, if you look in this perspective, is around $17 to 26 trillion. And we have to carve out what we can gain and what we can give to the world in return. The national rail target, Indian National Railway, is uniquely positioned to capture 10 to 15% of the global rail AI value through the aggressive deployment of the predictive diagnostics and the smart logistics. Now, Niti Aayog, in his document, prescribed two simple levers which will augment the output. One is the productivity and efficiency linked, another which is based on the innovations. If you say the objective in the productivity and efficiency is that we can bridge the gap of 30 to 35% of economic growth, this economic gap, by optimizing the existing operational assets via predictive maintenance algorithms. The impact will be we can curtail the maintenance expenditure by 25% and reduce the operational downtime by 30% or so. If we are able to imbibe the innovations into the system, it can contribute 20 to 30% uplift in the value capture. The mechanism is transform R&D using generative AI and advanced software modeling. This will create an impact of high-value software-defined R&D and the next generation rail components. The paradigm shift we have discussed throughout the yesterday and so far today, that the legacy interval-based system which is like hathoda chap. However, with the advent of so much of the media into the system, we often become reactive. So we have to have a caution that with the increase or infuse of the technology, this reactive system has to be totally left out. Reactive, breakdown-driven, and the schedule-driven maintenance system, it is somewhat like iron shackles and weight on our shoulders. Reliance on manual inspection and scheduled track recording are, yes, it is there, it is necessary, as long as we are not able to use AI or we are not able to go into the predictive maintenance system. So we need to disconnect. The existing system is disconnected purely physical hardware components, so we need to disconnect from this system and move forward and transition to a software-assisted rail vehicle systems where we can embrace the predictive, continuous in-service telemetry and sensor data. We can embrace the bionic organizational model functioning with over-to-the-air updates. So we will be always on to the toe, we will be having a continuous watch, and we will be able to have an effort, do when and how much it is needed and where it is to be done, rather than blindly performing everywhere without thinking forward. In this perspective, the predictive funnel for the infrastructure health can be, there will be certain input variables. The track quality index, what we have a TGI or track geometric index in our hand, this need to be converted into the quality related index. Not only the geometry, there may be other factors also. Then how much GMT is running on the system and what are the historical track defect records. All these things are the basic inputs. Based on that, the AI engine can look from the various types of tools available, like random forest algorithm, which is like a forest of so many decision trees which are working independently but in tandem. Finally, we will get out the outcome for a single product. And it will predict the occurrence of the probability of the spot geo defects where we need to attack. It will lead to the optimized output. We can have the Markov decisive process, which believes the current scenario is the scenario to which we have to attack and we need to solve the problem, rather than we keep dwell upon the old what was. And then we need to optimize via the value iterative algorithms. The research has shown that this type of system generates a 10% saving in the total maintenance cost per mile of the track. So if we are able to save a penny today, it will be invested a penny tomorrow, and it will generate a much more money day after. Now, the question is that how we are going to do the predictive analysis for a vast linear track structure. The challenge is dedicated track recording cards consume valuable network capacity and are limited to periodic intervals. The solution is deploy compact sensing devices directly on everyday in-service passenger and freight vehicles. To my understanding, we are using such systems in the Vande Bharat, but it is yet to formalize. These sensory inputs give the vertical lateral accelerometers, rate gyroscopes, and based on the Indian NAVIC receivers captures continuous car body vibrations, locations, and it will be able to produce the machine learning extracts featuring diagnose the track condition at 10-meter section resolutions. So if you are able to do that thing, I think it will be a very precise and accurate results. However, before it can be really infused into the system, there is a caution because the vehicle itself acts as a filter. So a lot of track defects that will be filtered by the suspension system of the vehicle, and it will not exactly replicate what it is. So we need to take that care also by utilizing suitable AI interface. Similarly, as we learned today, that the various turnouts has been fitted with the machines, and the machine itself can be developed or converted into a sensor system there itself, which can take various signatures. Similarly, every axle moving on the track itself can be capturing the signature, and if we combine these things together, then it is possible for us to do a better track diagnostics. Wavelet analysis is to be applied to all these signatures. This wavelet analysis will help us to segregate the low frequency wide spectrum signatures with high frequency spontaneous or very local signatures as shown here. So anomaly spikes can be captured and it can be taken care of by this wavelet type of analysis. It identifies spectral features corresponding to turnout wear immediately prior to the physical failure. It needs to be perfected. The second type of AI interface has to be made along with the subgrid radar detection. The faster regional CNN coupled with the ground penetration radar, it will able to give us a confidence what is happening at the location, and then it will go into deep and it will remove all the unwanted features which are coming across throughout the run. Research has shown that it can achieve up to 83.6% precision in recognizing the invisible track subgrade defects, for which we need to take, otherwise wait for the track subsidence and the track will start crying that yes, I have the problem, please come and rectify it. Next comes designing the bionic rolling stock models. Each and every rolling stock, we have seen today morning when we discussed about the locomotive related defect predictions. This can go not only to locomotive, but it can go to extend to the each and every rolling stocks. The software defined architecture should have the hardware systems, wheel, axle, locomotive in the pantograph, etc., integrated seamlessly with the continuous digital telemetry. While doing so, it will able to tell us when and which rolling stock is having the problem. But the problem is that it will generate enormous amount of the data, and that data really it is not possible to process and give the results. Therefore, the edge computing will help here. On the premise, pre-processing of this high frequency sampling data, each and every small unit which we are going to fit into the various rolling stock should pre-process it and then find out what are the exact defect or what are the problem, and then it should transfer to the system. In way, it will bypass the communication bandwidth limits. So, the prescriptive maintenance, we can move beyond predicting failure to AI system here that rank root cause solutions and optimize overall life cycle cost. So we need to take one more step ahead. Now when we are going component level deep diagnostics and the fault prevention, this vehicle onboard equipment, it will help us using the deep belief network, and again the research shows that 95% accuracy in isolating safety critical faults can be predicted by such systems. Similarly, in the overhead contact systems, pantograph carbon strip monitoring, yes, it has been told that they are becoming nowadays smart. It can be having combining with the deep learning paired with the LiDAR scanning. This will predict and prevent pantograph wear, particularly in case of our western corridor, where we are having the very high panto 3 meter or so. So because of the height, it will really prone to severe defect. Now, let us come forward and move to the predictive logistics, multi-layer perceptrons for ETA. It is not enough for us to predict the defects in the various components of the system. It will be helpful only when we are able to infuse or we are able to combine the system component defects along with the train operations. So when we are having all the inputs like the defects on one hand, system problem, and the train intensity, density, passenger train share, because we are having still some part entry or exit the dual system, the train length, gross mass. If we join everything together and we are having a multi-layer CNN system, in that case, the high degree of operational uncertainty of the mixed traffic network without fixed departure schedule, which we have mostly in the Indian Railway, that we are able to somewhat predict and solve with the AI architecture. With the multi-layer perceptrons, here it has been shown a 5-layer system. It can be less, it can be more. Again, the research has shown that the exact forecast of the mean average error is of the order of 0.08. Next comes the network intelligence and dynamic conflict management, digital twins. It has to be very judiciously select which are the conflict locations and point where we need to apply. Otherwise, it is highly costly, time consuming to develop. Then we can use the fuzzy temporal reasonings. We are having all uncertainty regarding the material behavior, regarding the material arrival or the components. In that case, we can use the when it is happening, which component is happening, and where it is happening. See, remember, we are a very linear system. So we need to predict all these uncertainties. For that, this fuzzy temporal logic will help us. Of course, then we must have the self-learning algorithm. We shall learn ourselves, we can modify ourselves so that we can continuously improve it. Safety is paramount. Whatever autonomous threat, we must detect it and able to prevent the accidents. Kavach, it should combine with the deep learning. One of the previous participants has already mentioned it. We are having the problem of this animal crossings, wildlife. So we have developed the Gujarat system. This is AI-based wildlife detection utilizing the optic fiber. It is helping. Then if we are combining the thermal and night vision together, it is possible for us to detect the obstacle about 1 kilometer ahead. That also need to be infused into the system. Now, future paradigm, braking limit. Morning we have discussed when we are talking about the Kavach 4 kilometer block, and the question was there whether it is possible. Yes, I fully support it. Instead of moving train by train and observing it in a distance of 30 kilometer, there can be a multiple train moving like a platoon of the trains. We can have each train operation than the cooperative control, and it is mentioned in some of the research papers that it can gain a capacity up to 30% increase, and in practice with the GOA 3 and 4, it has been implemented in the various international metro worldwide. Now come to the DFC. DFC 2 corridor, which has been already working, and they have a very distinct features, Eastern DFC and Western DFC. Eastern DFC is heavy haul dominant, prone to extreme structural stress and ballast fatigue. So focus should be axle load, analytical and structural health monitoring, and strategy impact, predictive maintenance on the bridge fatigue to prevent catastrophic coal supply shocks to thermal power. If we talk about the Western DFC, it is having container-dominant, high-frequency traffic prone to turnout wear and pantograph arcing. So focus should be machine vision, inspection system, and the deep learning OHE and wear management. This will eliminate en route mechanical breakdown to guarantee strict port arrival reliability for exports. We can have a three-phase strategy to Viksit Bharat. Phase 1 can be the foundational phase. That can be for 2 years or so, where we need to develop the launching innovation sandbox for the safe algorithm testing, and we shall generate certified professional rail engineers into the advanced AI. Phase 2, we can scale it up. In that, we can implement the system connecting across the major arteries, and we can complete certain hundreds and thousands of kilometers of fully operated smart corridors and mandate, and streaming the up to 25% of the new rolling stocks. And in the phase 3, there we can take a long strive and jump. We can really become the leadership. If we don't aspire that, I think we need to think over. Now, overcoming the roadblocks to the AI integration. First, the foremost is data silos and quality. Fragmented legacy system and unconnected rolling stock hinder the access. What we need to do? Mandate connected by design standard for all new OEM fleet acquisition. Skill gaps, several shortage of the professional bridging rail engineering and data science. Deploy agile operating models to fuse technology, business, and operational teams. Legacy retrofitting upgrade, bulky legacy core platform process, the multi-year delay risk. Deploy edge computing sensors as immediate scalable temporary overlays. Now, the privacy fatigue, OEM concern regarding the telemetry data sharing and ownership. Adopt India Data Management Office standards for the secure national interoperability. Final thing comes, systematic directives for the ecosystem. Who is to do what? First and foremost, the Ministry of Railways has to restructure legacy silos to bring technology, business, and operational teams into unified cross-functional units. Then RDSO and academia, they need to build strict safety guardrails for responsible AI, pressure testing models in sandbox before safety critical deployment. And the private industry and OEMs adopt India Data Management Office standard to prevent siloed legacy system and ensure hardware interoperability. Our actionable roadmap for the national AI integration. The Ministry of Railways can fund high-performance computing labs to process petabytes of the sensor data, implement agile operation to bring technology and field maintenance teams. RDSO and academia can establish railway AI chairs at the various institutes of national importance, including Gati Shakti Vishwavidyalaya. Prioritize explainable AI models via innovative sandbox before deployment to safety critical areas. And industries. Enforce industry-wide ontologies and IDMO standards. Contribute anonymized telemetry to the AI Kosh repository to seed national data sets. That is how we will be able to see or meet the national manufacturing data grids. Finally, I can summarize it, Indian Railways, the national enabler of the Viksit Bharat. The transition evolved from disconnected mechanical network to bionic software-defined nervous system. The impact, eradicating multi-hour breakdown delays, scaling capacity by 30% and unlocking the $1.7 trillion macroeconomic step up. The future, establish a globally competitive, AI-driven logistic backbone to secure India's manufacturing sovereignty by 2047. Thank you.
Thank you, Mr. Sharath, for the excellent presentation on making use of the artificial intelligence in the predictive maintenance of the track. I think one important perspective that you brought through your presentation was instrumenting the passenger and the freight trains, not only to monitor the degradation of the track, but also to monitor the condition of the rolling stock. I don't know how much of it is practicable, but then if at all it is, that will be the way to go. And on the Indian Railways, the other thing which you brought out is also a genuine problem on the Indian Railways, where we have the cattle crossings, the wildlife crossing, and the boulders falling on the track. If we can make use of the technology in preventing these kind of things or mitigating these kind of things, that will actually improve the operational efficiency a lot. So, moving on, our next presentation is on rail grinding. And as you all know that the rail grinding is an essential tool to maintain the costliest part of the track, that is the rail. Historically, the discussions on the rail grinding has always been focused on how it should be performed. But the more genuine question will be as to when the rail grinding should be performed, what should be the appropriate time for it. Grind the rail too frequently and you will increase the cost of the maintenance. Grind it too late and the rail damage might have already occurred. So our next presentation addresses use of the technology, the artificial intelligence in predicting the right time for the rail maintenance through the rail grinding. And this will be delivered by Mr. Manish Avasthi. The title of the presentation is Data-Driven Assessment of the Rail Grinding Frequency for Sustainable Track Integrity in the Indian Railways Dedicated Freight Corridor. So over to you, Mr. Manish.
Thank you, sir. Let me introduce my co-presenter, Mr. Venkat Rao. He is the Senior Research Fellow in the Vandana International Private Limited and expert in the field of rail grinding research. Regarding a presentation, I present with the constant resources we have, DFCC has fixed the rail grinding frequency as a 50 GMT. At present, DFCC has only one rail grinding machine. With the increasing traffic and making balance between the operations and maintenance requirement, we have to defer these rail grinding cycles. Now the question arises, up to what limit can we defer this rail cycle for the grinding? For this, DFCC along with our vendor partner, Vandana International Private Limited, has carried out some studies. Our presentation is based on these studies, indicating the methodology, what were the results and what were the conclusions. The study is mainly on the wear rate analysis, but yes, we have validated this analysis with the propagation of RCF, rolling contact fatigues and material degradation. At present, this study is entirely on the rail profile, but now in the next step, we are moving on and considering the wheel profile also, what was discussed yesterday during the presentations, and hopefully in the subsequent seminars, we will shortly be presenting our research on including the wheel profile also. This is our dedicated freight corridor project, which is fully commissioned. On the top, the blue shows the eastern dedicated freight corridor from Ludhiana to Sonnagar, and on the bottom, that orange color, we have Dadri to JNPT, the western dedicated freight corridor. The blue eastern has 90 UTS 888 gauge rail, and WDFC has 1080 head-on rail. We have done our some studies on both the type of rail profile, and we will discuss it in our presentation. To start with the western dedicated freight corridor, we will discuss first how GMT has evaluated in our western dedicated freight corridor, which has forced us to defer our defined grinding cycle. We will discuss, validate what are the RCF life cycle says. Then we will compare with wear rate analysis. We will also discuss material degradation, and then finally we will discuss how the head-on rail behave is essentially to the rail grinding. We have done this study in the two units of the western dedicated freight corridor, Ajmer and Jaipur. We have taken details on these 3 months, which we will be discussing in the subsequent slides. These are the evolution of the traffic, GMT. You can see on the left top, this is the Ajmer unit GMT evaluation. The orange bars are showing downline, and bottom below it, the blue line is showing the upline propagation. You can see the increase of GMT is very high, in particular on the downline. Up to March, it was only 9.92 ton. At GMT, it has gone to 22.56. In next year, it has gone to 22.15, then 44, and then 40. So every year, we are now having the incremental GMT of approximately 43 in this unit. Similarly, in Jaipur, on the bottom table, the incremental GMT is also high. If we see the right side table, it shows the how we have to force and defer our grinding. In Jaipur, we have done the first grinding in the month of May 24. After that, we have annual GMT of 43 GMT. So now cumulative GMT is 79. Means we have deferred one grinding cycle. Next row in Jaipur downline, the GMT is 58, average, cumulative 105. So now we have deferred two grind cycles. In the Ajmer upline, we have annual GMT of 59, average total GMT is 104. So we have again deferred here two grind cycle. And the worst condition was in the Ajmer down, where we have first grinding in the month of May 24. Average GMT here is 88 GMT. And cumulative GMT after the first grinding was 150, means we have almost deferred 3 rail grinding cycle. So our study is this, to what is the influence of grinding deferral, and at what stage shall we start our preventive grinding. This is the first regarding the RCF life cycle. You may be having the difficult to read, so I will just explain these the graphs, the left side top. This is the example where we have done the first cycle of grinding in the month of March 24. We have taken the picture in the month of August 24 and found very negligible or meager or known damages. The second picture shows on bottom is of March 25, where we can see the early sign of the RCF. In the month of June, the third picture, we can see these RCF are actively propagating. The next below is September. Now crack network has become very deeper. And in the last January 26, a significant deterioration we can see. So with the increasing of the GMT, we can see that the RCF is increasing. So this shows the table. The first, after the March 124, first up to initial grinding, we could not find any RCF. In the first 3 months, we get some starting of the RCF. 9 months of the deferring will show the moderate head crack. Then again, 12 months, it shows the expansion of this defect. 16 months, again increasing. And 20 months, a significant spalling and shelling will start. On 24 months, if it continues, however, we have now taken care of, there would have been an advanced fatigue deterioration. So for this, we have gone for the VR rate analysis. We have taken on a sample 3 curves of the Ajmer unit. All of the sharp curve 2.5 degree, where we have performed our study. This study was conducted by the 3 data. The GMT data were taken from our DFCC operations. We have taken the rail profile with the modern mini-prof, and wherever required for validating of RCF, we have used the DPT test. VR rate we have measured. VR rate was measured by taking the VR after the first grinding cycle, and then the date of measurement divided by the GMT into 100. So we have converted the VR into per 100 GMT. And subsequently, we are going to measure the VR rates. These are the VR rate. We will discuss the example of one curve is named at 207L. It is only curve of 2.5 degree. The top is the low rail demonstration. W1 shows the 0 degree rail top wear. W3 is the 45 degree wear. These columns are the wear which we have recorded in that particular period. If we see the table on the right side, we can see the 0 degree on the top. From March 25 to June 25, we have 27% of increase in wear rate. From June 25 to September 25, 13.9% of the wear rate increase, and September 25 to January 26, 32% of the wear rate increase. Similarly, on the 45 degree, that is the incline, we have 7.2%, 33.3%, and 30.33%. This is the low rail. If you go for the high rail, we can find some more value, which is more severe, obviously in high rail. In the high rail, if we go by the right side table, increase, which is showing the increase in wear rate. For W1, March 25 to 25, we have the increase in wear rate by 67%. From June 25 to September 25, 73%, and beyond that up to June 26, 6%. So we have data of these three curves for both low and high rate, which are shown here, and we have collected sufficient data with this. Now the question has come how to use this data. For this we have used the theory of inflection point. Inflection point says there will be definitely a point when there is a change in the two curves. So what we have done, we have plotted this wear rate, what we have measured earlier, in a graph. On the x-axis we have drawn GMT, on y-axis we have drawn the wear rate, and wherever we find sudden change in the wear, we have taken that point. We have find that initially there was a linear or a very small, very mild slope graph, and after a certain point the wear rate graph has gone to a steep slope. So that point we have taken as the inflection point. We will discuss it in the subsequent slide. From this left we can see the first chart on the top left, blue. It is the W1. We have given the points, I have drawn the points on the graph. We can see up to certain point this blue line is going mile straight, and suddenly there is change. We have extended the tangents of both the curve, and it is intersecting a point. That point we have taken as the inflection point. For the top of the graph, it is coming to the 57 GMT, where there is sudden change, and in the wear rate it is being steep. If you go for W3, same graph is giving 59 GMT. This is for low rail. On the high rail on the bottom, we can see that W1, again blue, we have extended both the tangents. It is cutting a point near about 63 GMT, and for red, we are getting this point at 61 GMT. So with this, we can say that this is the point where we must, this becomes the upper limit where we must intervene, we must start our grinding. This is the requirement. If we go beyond this, then there will be a much deterioration to the rail. This is for the first curve. Similarly, we have done for the other curve. It again says around 60 GMT. The third we have drawn, it is again coming to 64 GMT. This is again 64 GMT. So this we can conclude that we are more or less, we are getting the inflection point around 63 to 64 GMT. So this is, we found the wear rate where we can have the upper limit of deferral, and we should not defer our grinding beyond this point. We have also discussed, we have also noted this material degradation. We can see top on the rail. We have diagram. If you zoom, unfortunately we cannot zoom here. The first line, the black line, shows the UIC rail profile. The next is the green line, which would have been the rail profile for the normal rail when we measured in the month of October 25. But you can see the blue line, we can find some defects in the rail, which is not differing with the normal rail. Similarly, on the W3 side, we are the blue line shows the normal rail, and the purple line shows the defective rail. So it also matches, if you compare with the month, if we compare our RCF, if we compare with the model degradation, if we compare with the wear rate, we find all the three data are more or less violating, and we are finding in WDFC 60-65 GMT as a critical point. This is the same for next position. Coming to the sensitivity of the head hardened, what we have find that yes, this HS rail have superior wear resistance, being the 1080 head hardened rail, but it exhibits increased sensitivity to the delayed grinding, and therefore in comparison to 880 rail, they are more sensitive to the grinding. And in case of if we have to compare the same situation, we must go for grinding. We must give priority for the grinding of the HS rail. This was the study of the western dedicated corridor. For eastern, we have done the similar methodology. We have also somewhere where grinding had not been done, where we have given for we have done the study of the top photos, how it behaves. This is the first detail where no grinding was done in the section. Deterioration is found more or less same what we have found in the WDFC. This is again the second section where no grinding done till date. We have found again the prominent RCF, especially on the gauge faces, and rail contact surface here we found about 59 mm. This is the point to be noted where the rail grinding, the main point is to reduce our rail contact surface on the top, but where we had no grinding, we found that top of the width at 59 mm. These are the other photos of the eastern dedicated flight cut. And again, when we draw this diagram, we found similar, what would have been the normal rail profile, but after measurement, we find it much different where grinding was not done, especially when we have gone GMT beyond 70 plus, and even some section we have gone GMT 100 plus. When we compare the pre and post grinding details, we could find that after the grinding, we can reduce the wheel contact surface on the top. What was the 59 mm initially, after the grinding, it has reduced to 32 mm and 38 mm. Though we could not bring it to the 20 mm, but yes, with our initial grinding, we could reduce this from 59 mm to 32 mm or 39 mm. That was the achievement after the post grinding. Here again, we have drawn the wear rate analysis and found a similar pattern, but in this case, our inflection point was much lower than what we find in WDFC. If we compare from WDFC, here we have find that inflection point at 37, 38, and again 35, 37, 7 GMT. So on the basis of these two, we can conclude that the inflection point, or we can say on the behavior of our deterioration trend, our rail profile behavior, and our deferral. On the basis of inflection point, we can say that WDFC, the inflection point is 60 GMT, and that for EDFC, it is 40 GMT, and beyond this, rail deteriorated significantly, and therefore we must restrict our rail grinding before this. Deferral of rail grinding has increased the rail surface deterioration, and that the top of the rail wheel interaction has widened. And one more thing we have find, there is a need of efficient planning is essentially required with the balance of operations and infrastructure upkeep. Whatever blocks are made available to us, that we have to be utilized in the best possible way. This we have done some preventive measures taken by dedicated freight corridor. Systematic planning for the better utilization of grinding machine. We are now using the corridor block system for the grinding, and for opening of all the obstructions like axle counter, we are having our Teams which opens the Excel counter and refills the Excel counter without affecting the timing of the spark time of the grinding. So that we can better utilize our whatever limited block we have the facility. And now beyond this, we are going for what we have discussed, the real life extension analysis, RLEA. So this we are going with, where we can also conclude we can also have the effect of the wheel profile with our rail profile, which will finally give us the optimum point variable. And also DFCCIL has and shortly will be deploying 120 stone special rail grinding machine, and will also planning for some more on model for the rail mold grinding to effect. This is detail about it. Thank you.
Okay, thank you, Manish. You have brought out as to how the data was used to decide the maintenance timings for the rail grinding on the DFCCIL corridor, and I think that's the way to go for the operations like rail grinding, where when the traffic is increasing and the maintenance windows are shrinking. So another paper on the similar theme is from Prashant Kumar, and Prashant Kumar will be talking about use of the artificial intelligence in the wagon maintenance. And this paper actually represents a collaborative effort on the part of DFCCIL and Indian Institute of Science, which is again a premier technical institute of the country. And this explores one of the most ambitious applications discussed during this seminar, the development of the AI wagon examination system capable of operating at a speed of about 100 kilometers per hour. So over to you, Mr. Prashant.
Good afternoon. Good afternoon, ladies and gentlemen. So my topic is machine vision for train examination, challenges in building AI-based systems for wagon examination up to 100 kmph. I have with me my co-authors, Professor CHHRR&D from ISC Bangalore, sitting right to me, and Mr. Yashas, Chief Technology Officers from Lab to Market, next to Mr. CHHRR&D. So before going on to the main topic, I would just like to contextualize so that we appreciate the motivation behind the development of this machine vision inspection system, which has been deployed on DFCCIL. So a brief of how the maintenance of freight wagons is undertaken on Indian Railway network as well as on DFCCIL. So majority of the wagons running on Indian Railways are general pooled wagons. When I say general pooled, that means that these wagons do not have any fixed base. So they can be assembled in a rake formation at any place on IR network, in any of the yards, can be undertaken for examination at any of the examination yard, and then these can be moved to different loading and unloading points. So once these wagons are examined, so normally, it is given fitness for certain periodicity and certain lead distance. Maximum is they are given fitness for 30 days or 10,000 kilometers, whichever is earlier. And between two examinations, they undergo various cycles of loading and unloading. So during this whole process, these wagons undergo a severe vibrational loads, impact loads, braking forces that ultimately leads to progressive degradation in reliability. So besides examination in the yard, there is a need for examination, inspection at intermediate stages so that we can identify any defect which is getting developed and take appropriate corrective action. So traditionally, we are following a manual train examination system which has limitations. On DFCCIL also we are following this method, So there are 17 en route examination points on DFCCIL network. But these have certain disadvantages, like there's a reliability risk because the human judgment is subjective and the people can overlook certain defects and make certain errors. Besides, at a very high speed, these manual inspections are not very effective, and to bring down the speed so that the person can inspect is going to affect the operational efficiency. Besides, there is another disadvantage that whatever data these points are capturing, these remain locally available and they are not disseminated in real time across the network. So there was a need for automation of train examination, which was achieved through machine vision inspection system. So in this machine vision inspection system, the examination of the train is done at full speed of 100 kmph, and when the train is passing through MVIA zone, the defects are getting identified utilizing the state-of-the-art deep learning models, and the operation control centers have been provided with a very user-friendly interface for viewing these alerts so that appropriate action can be taken. On DFCCIL network, we have provided two MVI systems. So first one was provided at Daud Khan near Aligarh in September 2022, and another one was provided near Dehri on Son in September 2025. So first one was, it was a research project, and based on the learning out of the first MVIS, the second one at Dehri on Son was provided. So all examinations now occur seamlessly at full operational speeds at these 2 points. There is no requirement of manual inspections, and the defects are getting detected automatically, the alerts are getting generated, and now the examiner can focus only on targeted alerts instead of inspecting and focusing on each and every possible component that can develop a defect. Till now, we have successfully identified more than 97 such critical defects which would have led to the accidents. So how the system works, when the train is passing through MVIA zone, this raw data in the form of images is getting captured, and these images are being processed at the edge server level in AI inference engine, which has YOLO version 8. This is basically an object identifier. ResNet is basically a non-binary classification tool, and PADM is for anomaly detection. It is primarily a binary classification tool. And this AI generates diagnostic alerts and sends anomaly reports to the train examiner at Operation Control Center. And then a train examiner, after evaluating the alerts, and he also has access to the image of the exact defective component, can take a decision whether to attend to that particular defect or it can be allowed and the train can continue its journey. And this decision in the form of feedback is fed into the database so that the system keeps on learning and it gets retrained every time. This is the MVIS architecture. So at the end, there is a entry trigger in the form of FBG sensor. It's an optical sensor, which basically detects the arrival of the train, and this is sensed through the impact load of the wheel on the track, and it wakes up the entire system, and subsequent to that, so there are arrays of camera and other sensors on both sides of the track. So when the train is passing through this particular zone, the images are getting captured. The RFID reader is provided to capture the details of the wagons. And in between the two rails also, one line scan camera has been provided to capture the images of the undergear. There is all the edge server and DPU interrogator, network switch, and other hardwares are provided in the vicinity of this MVI zone in a porta cabin, where the processing of the images takes place. So this is the basic architecture that has been followed. Now, what challenges were faced when we tried to detect these defects at a very high speed of 100 kmph? The first one is the motion blur. So at a very high speed and capturing images of components which are as small as 1 centimeter wide, there is every likelihood that the images captured can be blurry, which then is difficult for the processor also to basically ascertain whether it is defective or not defective, as well as it is difficult for the controller also to make a decision. So this was achieved through a very high intensity lighting system which has been provided and which gives a very ultra short camera exposure time. Then camera frame rates were optimized to ensure that every single component gets captured at least in one frame. And this is achieved through a very optimal camera and lighting configuration through a combination of theoretical modeling and practical experimentation. Another challenge was how to detect the defect in real time. So basically these MVIs have been provided around 10 to 12 kilometers before the station. So it takes about 9 to 12 minutes for a train to reach from MVIS location to the next station, and the requirement was that the defect must be identified and published in real time before the train reaches that particular station. So this was achieved through GPU accelerated two-phase parallel processing. So in phase 1, certain critical or supercritical defects were identified, which basically needs to be attended on priority and which can result in catastrophic failures. And in phase 2, other defects can be reported, can be processed, which are not so critical. And even if the train is not stopped for some reason or other, there are no chances of any catastrophic failure. So the third challenge was capturing high quality data. So it was done through a very intelligent selection of the hardware, primarily consisting of global shutter area scan cameras, which captures an entire 2D scene with a high frame rate of 60 frames per second. Then line scan camera at the bottom of the train, which captures the images line by line and gives a very high resolution images of undercarriage, which is consisting of large number of small and bigger parts, and then an intelligent selection of right amount of illumination so as to reduce the exposure time and eliminate motion blur. Another challenge was that when the train is moving over the MVI zone, then the adjoining structures are subjected to heavy vibrations, and especially in summer seasons, there is a cloud of dust which basically can affect the working of these cameras, which are provided in the vicinity of the train itself. So these have also been specifically and especially designed to overcome these challenges. Another challenge was to select right specification industrial server for processing. Again, for the same reason that it has to process a very large volume of visual data and generate alerts, communicate that alert to the controller so that he can take that decision before the train arrives at the next station. Another challenge which was faced was non-availability of the image of defective components. So, because DFCCIL has no examination yard as such, and going to all the examination yard and trying to capture images or wait for some defective components to come in the rake and then capture the images would have taken a large amount of time. So what has been done that a multiple round of deliberations were held amongst DFCCIL, Mrs. L2M and ISC Bangalore, and we also visited workshops and yards, and thereafter we decided that we will generate the defective images with the help of computers. So computer generated images were generated of the defective components. Now this helped in very quick data set expansion and for very expeditious training of the machine learning model. So on the left hand side one can see some of the computer generated synthetic images which have been used in this model. This is again for the anomaly detection. The similar approach has been adopted. And state-of-the-art semi-supervised models like patch distribution modeling and FCDD has been used. These are some of the images of the defective components captured by MVIS deployed on DFCCIL. Going from the counterclockwise, first image is that of an open door captured at a speed of 98 kmph. Then next is an image of a crushed elastomeric pad, again detected at near to 100 kmph speed. Third image is that shows a dislocated spring, the rightmost spring, which is slightly dislocated, and that has been beautifully captured by the MVI system. And the bottom middle image shows axle box missing bolt, which is seen in the form of a black dot, a very small component, but it has been very clearly captured. And the bottom first image is that of a hanging part detected by MVIS. Now, if we see what has been the performance of MVIS system, so for a period of approximately 2 years and 9 months, if we analyze the data, then we see that the true positive rate comes to at around 98.75%. False positive rate is to the tune of 0.04%, and false negative rate is again 1.25%. And as the data set is growing, this accuracy, we hope that this will keep on improving. Now, this has been experience of DFCCIL with our existing MVIS, but we are not stopping here. So, we are again embarking on another journey wherein now we are trying to develop a more upgraded model of MVIS with multimodal architecture which will integrate 360-degree machine vision with defective wheel detection, hot axle, hot wheel detection, uneven load distribution detection, and body bulge detection. So what we are planning to do is provide a camera at the top also, and then we will use the FBG sensor which have been provided for sensing the approach of the train to measure the impact values of the wheel, which will be akin to wheel impact load detection system, because the similar technology has also been used in the wheel impact load detection system which has been provided on the DFCCIL. So this new MVIS will have a very enhanced capability of detecting a total of 66 different types of defects. Present MVIS detects around 19 defects. So there is addition of 47 more defects in this new MVIS, and again at a operational speed of 100 kmph. So some of the defects which we think that we'll be doing maybe first time in the world is detection of grease oozing in the axle box, broken lashings, especially those which are used for securing the steel coils, because that has been a regular problem noticed on DFCCIL network. Commodity alignment, again of steel coils, which is very critical because a slight misalignment can result into derailment of wagons. And also, since we are running truck on train services, so it will also help in detecting the alignment of the truck which is placed on a flat wagon. Now, since the WDFC is already complete and we are expecting a more traffic of container trains on the WDFC network, so we will also have certain application for detecting defects on the container trains, one of which is automatic twist lock defects. So this we are going to achieve through the new MVI system that we are planning, and we are soon going to enter into an MOU with ISC Bangalore and L2M Rail. And lastly, I would just like to inform that this MVIS, which has been developed under a collaborative agreement, has gone global, and one such system has been provided that is going to get provided on Mozambique railways very soon. So we are looking forward that whatever we develop here will also help and benefit the Internationl Heavy Haul Railways. So thank you.
Thank you, Mr. Prashant, for the presentation on the use of artificial intelligence in the train examination. So, ladies and gentlemen, the artificial intelligence is a technology that stimulates the curiosity. The more we learn about it, the more we think of using it in our decision support systems. So, this brings us to the end of the presentations, and I see there are very few questions. So, I take it either the participants are too eager to leave, or the presentations were very good and they have no questions at all. But despite that, I'll pass on the questions to the presenters. So we start with Manish, and Manish, you have 2 questions.
Shall I start, sir? Yeah. I have 2 questions, maybe from same delegate. Now, number 1 is how many rail fractures taken place in DFCC annually? What is the percentage reduction in rail fracture after introduction of rail grinding? What is the anticipated increase in rail life due to the rail grinding? This is regarding the rail fracture. Right now, if you go for WDFC, we don't have any rail fracture in the western dedicated freight corridor. Yes, we do have rail fractures in the eastern dedicated. This study of defect generation rate, DGR, this we have just recently included in our one of the agreement with our vendor partner VPIL, and we will be studying this, what is the effect of rail grinding on defect generation rate. So shortly I think we will come to know about these details. What is the anticipated increased rail life due to rail grinding? Right now it is too early to say, but it is expected about 25% of the life is being increased with the due to the rail grinding. Second question is that if there is so much delay in grinding, why there is delay in procurement of the buying better machines, and what are the technology in DFCC investing into solve the rail surface damage problem? Right now we have only one rail grinding machine, but we shortly will be getting one special rail grinding machine from the Indian Railway, and we are also looking for some service model of 90 stones rail grinding machine very, very shortly. So hopefully we will be able to at least achieve what we have shown today, the inflection point. We are sure that we will be able to achieve those inflection point. Third question from Prashant, you.
So,
I think, Prashant, two more questions have come. You can read them and group them if they are similar and answer to them.
So, first question is, what is accuracy percentage level of MVIS? So, I had already covered in my slide that presently, and how accuracy level is calculated. So, one of the method is to calculate the precision. So, precision is basically true positive divided by true positive plus false positive. So, that percentage comes at around 80% presently. But then again, based on the expansion of data sets and more training of the machine learning model, this value keeps on increasing. And since MVI system is, for whatever we have deployed, is relatively new, so it is operating at this level. But again, it will keep on improving in times to come. Can it fully replace manual examination? If not, how much time can it save in examination? Is any study being done in time saving? So, this MVIS cannot completely eliminate the manual examination if you are talking about the yard examination. So, if you provide before any yard, examination yard, and if you think that it is going to capture all the defects and there is no need of manual examination, then in my view, it may not be possible. Because ultimately there are certain components which may not be immediately visible, because if you look at the underframe, there are a lot of shadow areas where the cameras cannot detect. Then there are certain defects like a very minor crack which can only be inspected visually. So it is not going to completely replace the manual examination. That is my view. But again, it depends upon how the technology evolves. Maybe this may develop in times to come. Yes, it can save the examination time, because if you provide before the yard, then by the time it reaches for examination, you have a certain information about what kind of defects are there. So you can immediately plan your maintenance even before arrival of the train. So it will definitely help in saving the examination time. Is any study being done in time saving? So right now, a proper MVI system has not been provided on Indian Railway network. DFCCIL along with Mrs. L2M, we are providing fourth such system on IR network, and this is being done under an MOU which has been signed between Railway Board and DFCCIL. So once these systems are operational on IR network, then we'll be able to do these kind of analysis, whether how much time saving can be done. So this is for the purpose of track maintenance at the site of MVIS. How much time does it take to remove MVIS of the track and put it back into operation? So I think, would you like to answer it? So I'll request Yashas to please.
Yeah. So for track maintenance, only sensors are being installed to see the triggering of the system. The cameras and the lights are installed on the side of the track, so they can be easily dismounted and can be easily installed back.
So I would also like to add that over the past 1 year, we have examined 4 million parts, which would have been impossible for manual examination.
Another question is, how can the MVI system be replicated on board the loco or wagon as being developed by IR on AI analytics-based visual surveillance system? I think the philosophy and the technology is more or less same. So I don't know about the wagons, because again, wagons, they do not have anything which can really power up these electronic systems. So I don't think it is possible on the wagons. Yes, but of course on locomotives, it can be done. On DFCCIL, we have similar applications like track recording car, OHE inspections car, wherein the similar technologies are being used. So it is possible on loco, but may not be possible on wagons because of the availability of power issue. How do you identify the criticalities of that? So another question, how do you identify the criticalness of the defect? Is it by identifying the size or geometry of the defects? So the criticalness of the defect, the philosophy that we are following is the defect which can lead to derailments or a very catastrophic kind of failure are considered to be a critical or very supercritical defects. For example, a door missing is not a critical defect because it is not going to cause a derailment. Door hanging again on DFCCIL network, it is not a critical defect because we have a higher maximum moving dimensions. So it is not critical for us, but it may be critical for IR. So maybe IR, when it is operated on Indian Railway network, then they may have a different definition of critical defects. And for example, axle box bolt missing, that is also not very critical. So, but a hanging part is again a critical defect because it can immediately lead to derailments, or a crushed EM pad is a critical defect because it can cause imbalance of the wagon loads and cause derailments, especially on the turnouts and the points and crossings. So this is how we classify whether a defect is a critical or non-critical, depending upon what kind of impact it has. And is it identify the size or geometry of the test? I hope this answers the question. I think my questions are
okay. Thank you, Manish and Prashant, for the answers. So as the moderator, it has been a privilege to facilitate this last session of the seminar. My sincere thanks to all the participants who have presented thoughtful presentations which have evoked the interest in all the participants. And I also thank them for the generous sharing of the knowledge. You all have made this session very informative and enjoyable. Thank you. Over to you, Jui.
Thank you very much, sir. As we conclude this session, we have been reminded that sustainable success in heavy haul operations is built not only on infrastructure and technology, but also on the ability of institutions to learn, adapt, and continuously improve. As we move further, may I take the opportunity of requesting Mr. Pramod Kumar Chief Vigilance Officer, DFCCIL, to kindly please present tokens of appreciation, respect and honor for each of our speakers for this session. Beginning with Mr. Anmol Kaul. सभी का बहुत बहुत आभार, अपनी एक्सपर्टीज़, अपने नॉलेज, व्यूज़, आइडियाज़ सभी ने हम सभी के समक्ष आज शेयर किए हैं. थैंक यू फॉर योर जेनरस शेयरिंग्स इज ऑल्सो mentioned by the moderator. Ladies and gentlemen, here is the first memento, the DFC memento. Please join hands as we thank each of our speakers. We have a very special symbol of national unity and pride, the Statue of Unity. Towering monument dedicated to Sardar Vallabhbhai Patel. And also a technical compendium of the seminar. Thank you once again, Mr. Anmol Kaul. We thank Mr. Sharat Kumar Agarwal for his sharings. Thank you very much, Mr. Sharat. And we would take a moment to pause and thank each of the esteemed panelists for giving us their time and sharing their knowledge with all of us today. The world's tallest statue, standing at 182 meters. Followed by a technical compendium of the Internationl Heavy Haul Seminar 2026. A round of applause, ladies and gentlemen. We thank Mr. Manish Avasthi for being here with us in this session. Thank you, Manishi, for your presentation, for sharing of knowledge from your side. And here is the DFC memento to start with. The Statue of Unity. And the technical compendium. We thank Mr. Venkat Rao for sharing his knowledge with all of us for that presentation. Thank you very much, Mr. Venkat. Tokens of appreciation and respect for each of our presenters for being here with us and joining us in this seminar. So once again, a big thank you to the presenters. We thank Mr. Prashant Kumar for your presentation, your time, expertise, thoughts, all of which you have shared with us today. So we begin by presenting the special DFC memento. And a round of applause once again. Thank you very much, Mr. Prashant Kumar, for joining us in this session. Professor CHHRR&D. Thank you very much, Professor CHHRR&D, for sharing your thoughts with us today. Thank you to all our speakers. And the moderator, Mr. Manjul Mathur, for conducting the session, for moderating this panel discussion. Many thanks to Mr. Manjul Mathur. Ladies and gentlemen, once again, a round of applause for the moderator, Mr. Manjul Mathur. So we have the memento here, the DFC memento. Please join hands. The world's tallest statue, the Statue of Unity. Thank you very much. Ladies and gentlemen, we have arrived at a very interesting moment. We had been waiting for the announcement of the lucky draws, and this is the moment for it. May I please invite GGM IT, DFCCIL, to kindly please join us for announcement of these lucky draws.
Good evening, ladies and gentlemen. It's my unique pleasure to draw you away from karma, intense brainstorming, technical presentations, and discussions towards Kismat, the draw of luck. In recognition of your contribution in making this seminar a unique and successful event, the Managing Director, DFCCIL, Chief Patron, has decided to let each one of you get 10 shots at your luck. The eligible participants for this draw of lots are the delegates, the speakers, and the organizers. As you look at the screen, all the participants who have enrolled themselves and who have attended, and as IT, I have this unique knack of tracking people who have come to this event to attend this event. Their names are being loaded on the screen. The rules of engagement. On the draw of this digital spin, one unique participant's name would come up as a winner on the digital platform. I expect a show of hands in the 5 seconds time succeeding the draw of name. Otherwise, the wheel spins again. The person who is missed or who has already been awarded gets excluded from the subsequent spin. A pat on my own back. The application has been developed in-house in last 36 hours, and therefore, the only ineligible person to be awarded is me. With the permission, sir, we'll move to the first spin, sir. So total there are 10 set of awards. The 10th prize is the Philips sandwich maker. 9th prize, Samsung wireless battery pack. 8th prize, Philips mixer grinder. 7th prize, LG microwave oven. 6th prize, Noise smartwatch. 5th prize, Philips air fryer. The 4th prize is Noise Masterbuds Max headphones. The 3rd prize, JBL Flip 7 Bluetooth speaker. 2nd prize, Lenovo Tab M11 with pen. And the grand prize is a 32-inch LG Smart TV. A word of caution for all the delegates who have come from outstation. I hope you are ready to carry the excess baggage back home. Thank you. We commence with the round 10. Let's go with the spin. A total of 437 participants over the last 2 days engaged with us. And the first prize goes to Mr. Sachin Punetha, 5, 4, There is. Please come forward. Please come forward. I'll request the managing director to kindly do the honors and give away the prize. Congratulations, Mr. Punetha, for the Philips sandwich maker. So the 10th prize goal is claimed. Let's spin for the round 9. You see the count has gone down to 436. Mr. Punetha is excluded from this round. Mr. Mrityunjay Verma, round 9, show of hand. Congratulations, Mr. Mrityunjay Verma. Mr. Mrityunjay Verma wins a Samsung wireless battery pack. Let's look at round 8. How many are sweating? Round 8. Spin of wheel, please. Mr. Rajbir Singh from Dedicated Freight Corridor. Congratulations, Mr. Rajbir Singh. You win the Philips mixer grinder. In recognition of your grinding efforts in the civil department. Let's move to the round 7, spin of wheel for round 7. Kindly hold on to your breath. You just might have a lucky shot today. Ms. Renu Agnihotri from the HR department of DFCCIL. Tremendous. 5, 4, 3, 2, 1. Unfortunately, she is not here with us. Let's spin again. Mr. Ajit Kumar Bias. Mr. Ajit Kumar Bias, 5, 4, 3, 2, spin again. Vladimir, get ready to have some excess baggage back home. Vladimir is not there. Round 7, Mahendra Singh Dhoni's number is proving to be difficult to replace. Spin again. Mr. Rajesh Gaur, 5, 4, 3, 2, spin again. Mr. Rajnath Yadav, congratulations, finally, the 7th round goes to Mr. Rajnath Yadav. You win a LG microwave oven. You cooked us before reaching here. Let's spin for the round 6. Mr. Surendra Singh from the Civil Department of DFCCIL. Civil Department looks to be lucky and is present. Congratulations, Mr. Singh. for the Noise smartwatch. Huge round of applause for Mr. Singh. He's been lucky. Let's spin for the round 5. Spin. The Philips air fryer is waiting for you. Mr. Vivek Singh, 5. Well done, move fast. You won. If I reach 1 before you if you don't reach before 1, you might lose it. I think the countdown has to start. 5, 4, 3, 2. Well done. Congratulations, Vivek Singh. Let's spin for round 4. Round 4, spin. Mr. Anirudh Roy, congratulations. Noise Master Max headphones. The intensity of clapping is going down. People are losing hope. 3 more rounds to go. Round 3. Spin for round 3. Mr. Kaushik Nag, you're lucky. Congratulations, Mr. Nag. JBL Flip 7 Bluetooth speaker. Let's move to round 2. Spin for round 2. Mr. Vipin Parihar. Oh, he's there. Great. He has broken number of hearts. He's there. Lenovo Tab 11 with pen goes to Mr. Vipin Parihar. Civil department is rocking. Truly, Internationl Heavy Haul Seminar. Time for the grand prize. And the person should have good muscles. 32-inch LG Smart TV. Spin. Ishant from the admin department. Tremendous. Congratulations, Ishant. Ishant is the proud winner of 32-inch LG Smart TV. Congratulations. Thank you, sir. Thank you so much. I hope all of you did get a fair chance at your luck. And congratulations to the 10 lucky recipients of the awards. I'll hand over to the Master of Ceremony now. Thank you.
Thank you very much, Mr. Alok Shankar Pandey. Bar zordar thaliyan ke liye. He conducted it really well. All of us enjoyed the lucky draw announcements, and I think the draw was really interesting. So before moving any further, there is a special recognition for Mr. VP Bhatia from ITPO, who has helped us a lot in, presenting this seminar and making all the required arrangements. May I please request Mr. Bhatia and to please come forward and request our MD sir to please present a token of appreciation for Mr. VP Bhatia from ITPO.
Thank you, sir. I would again request MD sir to recognize our Juhi for outstanding anchoring. She has anchored this event seamlessly with poise, elegance, and energy. Miss Juhi, a big round of applause.
Thank you for that honor. Ladies and gentlemen, community is not just another stakeholder in the business, but the very purpose of existence of any enterprise. As we arrive at the conclusion of the Heavy Haul Seminar 2026, we can look back with a deep sense of satisfaction at 2 days of enriching discussions and invaluable exchange of ideas. The dedicated freight corridor is a remarkable example of turning vision into reality. Today, DFC carries more than 13% of Indian Railways freight traffic, demonstrating its growing contribution to the nation's logistics ecosystem. The approval of the East-West dedicated freight corridor stands as a testament to the success and strategic importance of this vision. Behind every great institution stands its visionary leadership. Our managing director has been part of the DFCCIL journey for the last 15 years and has witnessed its transformation from a plan on paper to the commissioning of the entire 2,843 route kilometer of DFC. Under his leadership, DFCCIL became a member of the Internationl Heavy Haul Association, that is IHHA. It is therefore fitting that many in the railway fraternity fondly refer to him as the Freight Man of India. Ladies and gentlemen, with this, may I please request, sir, to address the gathering now. May we please request you to present your thoughts and also present the closing remarks.
Thank you, Juhi. Now we are on the verge of closing this seminar 2026. Let me summarize what has happened during 2 days. Distinguished guests, colleagues and friends, as we bring the second Internationl Heavy Haul Seminar to a close, allow me a few words of gratitude and a thought on the road ahead. First, my sincere thanks to Ms. Carrie Gonzalez, Chairperson of the Internationl Heavy Haul Association, for her presence, her insight, and the IHHA's continued partnership. Your engagement lends this forum its global standing. My thanks also to all co-hosts, the Center for Heavy Haul Rail Research and Development, for standing with us in shaping this seminar. To our speakers and panelists who have traveled from across the world to share candidly what decades of operation have taught them, thank you very much to all of you. And to our partners from industry and our sponsors, thank you for your commitment. Finally, to my team at DFCCIL, our directors, our executive directors, all my team, right from bottom to top, whose dedication and hard work made as these 2 days possible, you have my deepest appreciation. Over these 2 days, under the theme of engineering reliability at scale, we have moved from the fundamentals of reliability engineering under sustained loading through condition monitoring and systems intelligence to signaling, strain control, and our journey with Kavach. What strikes me the most is not any single presentation, but the common thread running through all of them, that reliability is never the achievement of one asset working well, but of an entire corridor consisting of track, rolling stock, overhead equipment, signaling and operations working as one. The candor with which our global colleagues shared both their successes and their hard-won lessons is precisely the spirit this forum was created to foster, and it is a spirit we must carry into our daily work. We have now completed 2 editions of this seminar. That is a genuine feather in our cap. The template is set, and DFCCIL must now carry this forward every year in a planned and deliberate manner until our International Heavy Haul Seminar becomes a landmark event on the global railway calendar. DFC would always be grateful to Ministry of Railways for providing full support for organizing such type of international seminars. As we look ahead, 2 commitments must remain at the very center of this discussion. The first is safety, and the second is innovation. We must keep studying the best technology and use the cases the world has to offer and adapt them, as Ms. Carrie Gonzalez in her initial presentation, she told, for adaptation, not copying. Thoughtfully for India, our task is not merely to adopt what exists, but to learn quickly, institutionalize what works, and set the benchmarks the wider system can build upon. Furthermore, with the proposed east-west dedicated freight corridor and the pipeline beyond it, the opportunity before this room is large, real, and only just beginning. To the technology providers, OEMs, researchers, and operators, my appeal is simple: stay engaged well beyond these 2 days. Come to us, come and discuss with DFCCIL. We'll be very ready to discuss and deliberate with you. Bring your technology, make it in India, and build it with us. Designed for reliability, delivery, safety from inception. Let this seminar be remembered not as an event we hosted, but as a tradition we began. I look forward to welcoming you all again next year. Thank you all. Jai Hind.
With optimism for the future and confidence in our collective capabilities, we formally conclude the Heavy Haul Seminar 2026. Ladies and gentlemen, once again to mention that we are all organizing a guided tour of the heritage landscape on Kartavya Path. The tour will start at 8 a.m. tomorrow morning from Rail Bhavan, covering Vijay Chowk, President House, War Memorial, and India Gate. Interested members may kindly register their names at the registration desk. Thank you very much, ladies and gentlemen, for joining us here in this 2-day seminar. For all our international delegates, we wish you a safe travel back home. Thank you, and looking forward to meet you again next year. Thank you very much. Thank you. With this, we invite you for another refreshing tea and coffee that is waiting outside for all of us. Please join us for the high tea. Thank you.